This is the time as a country we have to come together, we have to stay calm.
दोस्तों, बचाव आपके स्वयं के हाथ में है. आपके परिवार का, आपका, देश का बचाव सिर्फ आपके हाथ में है.
पैंडेमिक में सबसे जरूरी यही है, रिसोर्सेस का वहां इस्तेमाल होना जहां उसकी जरूरत है.
हम आपके लिए काम पर रहते हैं, आप हमारे लिए घर पर रहें.
मेडिकल स्टाफ, नर्सेस, डॉक्टर्स हमारे लिए बहुत मेहनत कर रहे हैं.
Hats off to you all.
Thank you.
Thank you.
Thank you, doctors.
Thank you, doctor.
Today we're going to be making a robot which is a must build at home. So let's get to it.
അപ്പോൾ നമ്മൾ ഇന്ന് ചെയ്യാൻ പോകുന്നത് ഒരു വെറൈറ്റി ഡ്രോൺ ആണ്.
तुम्ही बघत आहात लर्निक्स मराठी, जिथे आपण शिकणार आहोत
how to invest on debentures and earn a little bit more than what you can.
पढ़ले बेटा, पढ़ले.
We are here today to learn about chemical reactions and equations.
How to study smart and not hard and be much more effective.
Some very simple hacks for watering hanging plants.
Learn something new every time.
Today I'm going to take you through Surya Namaskar.
Hey guys! Welcome back. This is Harsh Singh and I welcome you all to DSC OMG Day 3. Welcome to the place with some awesome content, some cool badges, unlimited networking opportunities and a hard-working team to make this event come alive for you. This is Cloud ML Track, and what do we have in store for you today? But before I tell you what we have in store, I need some interaction from you guys. So get your hands on the keyboards and answer the coming questions. I need this to be super interactive, guys. Let's make this happen. The question is, क्या आपने कभी अपना मॉडल ओवरफिट किया? टाइप इट डाउन. क्या आपने कभी अपना मॉडल ओवरफिट किया? क्या आपने कभी किसी को जीसीपी क्रेडिट दिया? और क्या आपका भी एरर रेट बिल्कुल कम नहीं हुआ? जी हाँ. If this, yes, then this is the place for you. We have today with us a person from TensorFlow at Google, a new awesome speaker, Animesh, talk about project Akina and the treasure itself. A DSC leads alumni panel waiting for you. But do we do it alone? No, not alone. Alone we can do so little. Together we can do so much. On those lines, the lead and the core team from across the nation join hands again to begin this day 3 of something as big as this 5-day OMG event with 20 OMG speakers. Without taking any more time, I will call upon Josh Gordon, who is a developer advocate at TensorFlow and teaches applied deep learning at Columbia University and machine learning at Pace University. Keynote for day AI/ML with the topic, the latest tutorials, educational resources for TensorFlow 2.2.
Thank you so much. How's it going, everyone? Can you hear me okay?
Yeah, it's great to have you, sir, onboarded, and we are looking forward to your talk.
Thanks. Yeah, I really appreciate it. I know my camera's in a weird place. I just set up my apartment in New York. But so yeah, really appreciate it. Hope everyone's having a great day. And let's dive in. So I hope you can all see my screen. I know the resolution's a little bit high. And what I wanted to do is point you to some solid educational resources for TensorFlow.js, so machine learning in JavaScript, TensorFlow Lite, which is machine learning on Android and iPhone, and importantly, microcontrollers, and then of course, Python. And I'll just point you to some of my favorite demos and the latest educational resources. So for people that are new to machine learning in JavaScript, most of what we do is in Python, but I'd really encourage you to try out machine learning in JavaScript if you haven't already. And the best place to get started with that is TensorFlow.js. And using TensorFlow.js, this is a relatively new website and the tutorials are pretty good. You can write machine learning that runs entirely in the browser. And the reason this is important is if you're thinking about deploying models, because it runs in a web page, all you have to do is publish a web page and it's instantly available to developers around the world. You don't need to manage your own servers. Also, because it's in a web page, you can build interactive machine learning applications. And if you check out this blog post, I know it's tiny, but hopefully it's recorded so you can find the link. You'll see 2 of my favorite recent demos. And you can actually build applications on top of these. So there's 2 ways to use TensorFlow.js. One is you can write your own machine learning programs from scratch. And 2, you can build on top of existing demos. And so if you look at this is a program called Face Mesh. And it's running in real time entirely in the browser. So nothing's being sent to the server. And if you look, it's actually quite accurate. It's giving you points all over my face, key points like my eyes, my nose, my mouth. And you could use this to build any number of interactive games or applications. You could use this to potentially control the mouse for people with disabilities. And there's a lot of cool things waiting to happen. In the same family as Face Mesh, this is a demo from a friend of mine called Pose Animator. And it's sort of like a free version of Animojis on iPhone. And what it's doing is it's using body tracking and face tracking to animate a little character based on what you're doing. And it's extremely cool. So again, you could use this for games and animations. And then there's more opportunities too. Let me see if I have a hand tracking demo. I have one more amazing demo. If I can't find a link, I'd encourage you to check it out. It's the hand tracking. And it's in the same article. And this is extremely powerful. You can get key points corresponding to somebody's fingers and hands. And again, you could use this to control games or for people with disabilities or anything like that. The best way to learn about machine learning in JavaScript is this book, Deep Learning in JavaScript. And the good news is this is based on Keras. And so it's these same high-level APIs that TensorFlow 2 is based on, and they're very, very similar in JavaScript. The book also has a GitHub repo that you can take a look at. So Deep Learning in JavaScript, it's written by the TensorFlow.js team and Francois Cholet, who wrote Keras. The other area, oh, and more cool demos too. On the TensorFlow.js webpage, if you'd like to play some games, you can also play Pac-Man in the browser. And when you're playing Pac-Man, you control Pac-Man by actually training an image classifier on the fly. So yeah, it's extremely cool and new area. And there's the Pac-Man game. You basically control it to train it to recognize different pictures. So for example, if you're smiling, Pac-Man can go up. If you're sad, Pac-Man can go down, and so on and so forth. Another area that I'd encourage you to check out. So that's JavaScript and a lot of potential there. Another really important, relatively new area of machine learning is called TinyML. And a lot of what we've done in the last 10 years in deep learning has been running on larger and larger devices. So that includes things like GPUs and TPUs and server farms and all that. And the question I think in 2020 is how small of a device can we run machine learning on? And what that means is potentially a microcontroller. So a microcontroller can be something like an Arduino. It might have a 20 megahertz processor. It might have 1 megabyte of RAM. It might cost anywhere from, if you're manufacturing them in industry, from 15 cents all the way up to $40 if you're buying one yourself. But in TinyML, this is basically the study of developing models in TensorFlow and Python, and then converting them to C to run on these tiny microcontrollers. And this is a really good article on our blog. This is the TensorFlow blog. It was actually written by some really good engineers from Arduino. And it's basically a tutorial that walks you through running a speech recognition model on this little microcontroller. And here it's doing something called keyword spotting. So it recognizes if you say yes or no, and you can retrain it for your own phrases. Other things to think about. This Arduino has an accelerometer on it. So what they're doing here in this demo is they're using the Arduino to recognize if you're making like a punch or an uppercut, and they're displaying the gesture you made on the laptop screen. And of course, you don't have to have this thing plugged in. You can also use this thing for computer vision. And the reason I wanted to point you to TinyML is this is a brand new field. It's really about a year old. There's not many resources for it yet, and I think it's going to be increasingly popular. Let me see if I have a link to it. Harvard TinyML. Most likely, although we can't promise, there's going to be a course from Harvard on tiny machine learning, and possibly the videos will be available online in the fall. So if you search for TinyML Harvard, you'll be able to find just the cutting edge stuff. If you'd like to learn more about TinyML, I also have a book recommendation for you. It's the only book on TinyML, and it's also the first one, and it's called TinyML. And this is written by two friends of mine who were engineers on TensorFlow Lite. Also super, super cool. So TinyML. Then let's move into Python. So at TensorFlow.org/tutorials, that's the best place to find what will soon be the latest resources for TensorFlow. Typically every summer, my team does a lot of work updating our tutorials and guides. So we're all sort of heads down right now, having lots of coffee, writing a lot of new stuff. Basically, if you're brand new to TensorFlow, here's the easiest possible way to get started. On TensorFlow.org/tutorials, we have two collections. We've got, unsurprisingly, we have beginners and we have advanced. The important thing that I want to show you is that every single tutorial on the website, you can read it because it's a web page. You can find it on GitHub, great. But the most important thing is running it in Colab. So if you're new to this, you click Run in Colab for every single one. And this is a free Jupyter environment that runs in the browser. It has a free GPU. To enable the GPU, you go to Edit, Notebook Settings, Hardware Accelerator, and check GPU. And then you hit Save. And then for any of these tutorials, you can do Runtime and Run All. And you can interactively run everything we've got right in the browser. And the best place to start, one thing that I wanted to mention about TensorFlow that might not be obvious is it's by far the world's largest open source framework. And this means that it can have a bit of a steep learning curve, but it also means that once you learn TensorFlow, pretty much, it's very easy to use pretty much any machine learning framework that exists today. And roughly, TensorFlow has what we call styles, code styles for beginners and for experts. And so I don't like to use slides, but I have some slides that will sort of show you what this looks like. Very, very roughly, I'll just show you. Too many tabs. There are different ways to define and train your neural networks. The simplest possible way to define your network is using something called the Keras Sequential API. And this is basically a stack of layers. And the simplest way to train a neural network is using the simple model. It's just a one-liner, model.fit. So you can define and train networks in a few lines of code, which is awesome. If you would like to do something more advanced, you can also take a look at tutorials like this. And this, we're actually going to move to the basics section, even though it's in advanced. But it's showing you a different style that you can use to develop your models. And let's see. Actually, just kidding. We have to update that. Let me find you a different one. We'll look at this one. So this is a tutorial for a GAN. And another way to, that's not what I want either. Now I'll just look at the quick start. Another way to define your models is by doing what feels like object-oriented programming. And so here, we're defining a model a little bit how you define a class in Java. And in the constructor, you define your layers. And in the call method, you define how the data flows through it. So this would be instead of using the sequential API. And then if you want to write your own training loop, instead of using model.fit, you can write that all from scratch. And so this gives you control and hackability where you need it, and very easy APIs when you don't. In terms of new features, when you run these tutorials and you print out the TensorFlow version, so let me run this really quickly, and I'll show you what version of TensorFlow we're running. So if you print TF version, you'll see this is 2.2, and we're working on 2.3 right now. 2.3 you can install by doing this, pip install tf nightly, and there's a lot of output, so you might want to run it in quiet. But if you install tf nightly, and then you have to do runtime and then restart, so Colab restarts the Python interpreter, and then you print out tf version, you'll see 2.3 development, and then the day it is. 2.3 is all about loading data and pre-processing data. And it has a lot of new utilities and layers that are experimental that are very powerful and very helpful. And TensorFlow is largely based on Keras. And I wanted to point you to the Keras website because that's where you'll find the latest tutorials that are using these new experimental features. So for example, this is the new image classification tutorial, and TensorFlow will eventually, when these are stable, we'll have very similar code on our website. And if you look in here, and you search for the word experimental, you'll find these new utilities we're working on. And just so you know, to run this tutorial, you can also open it in Colab. But in order for it to work, you're going to have to add a code cell, and you'll have to do pip install tf nightly. And then you'll have to, after you run that, do runtime restart and runtime run all, and you should be able to run this. But if you go through this and you search for experimental, I got too many tabs. I'll just show you here. You'll find a couple things. The most interesting thing are these Keras preprocessing layers. And basically, we have these for images and for text, and they let you do the pre-processing for your data inside your model. And let me show you what the model looks like. This is one way of defining a model in TensorFlow, but what's new is that the data augmentation and the pre-processing can be part of a model. So for example, this is actually better to illustrate with text classification. Let's say that you wanted to develop a text classification model and then in Python, and then deploy it in JavaScript so it could run on a web page. One of the things you have to do when you develop a text classification model is you have to vectorize text. And that means basically if you have a word, you have to turn it into a number so you can feed it to the neural network. And typically you write a bunch of code in Python to do that, which is fine. But when you deploy your model in JavaScript, you have to rewrite all that pre-processing code in JavaScript to convert words to numbers. And that's a lot of work, and you probably don't want to do it. In TensorFlow 2.3,
hey, hello, Josh.
Yes.
Just a minute. Can you zoom in on the screen, on the presenting screen that you have?
Yes.
Yes. Can you take it on the single hand? We are able to see two screens right now. One on the StreamYard and one on the presenting screen.
Ah, okay. Yeah. So hopefully, I know it's really tiny. Hopefully, you can rewind with the video and see the links. Maybe I can make this much bigger. How about now?
Yeah, that works great.
Perfect.
Thank you, Josh.
Yeah. So for instance, there's this new layer called experimental text vectorization. And this lets you embed inside your neural network all the code that you need to pre-process text. And this can make deployment much, much simpler. So basically, there's a couple other utilities we're working on in TensorFlow 2.3. And these are basically just ways to load your data off disk. And so you'll see little utilities like Keras preprocessing image dataset from directory. And this is just, it's just a fast way to load images in an efficient format. And so basically, yeah, 2.3 is all about loading and preprocessing data. And those are coming up. I've been using them for a while. I really like them. And I think you'll have fun with it. The best way to learn about TensorFlow 2 is this book. And I know I'm throwing a lot of resources. I'll recap them at the end. This book is called Hands-on Machine Learning. The GitHub repo is great. Here's what the book looks like. The most important thing is there are 2 versions of this book, and only get the 2nd edition. And the 2nd edition is the one with the word Keras in it. Basically, TensorFlow 1 is a much older framework. We learned a lot since then. TensorFlow 2 is a lot easier to use. So this is the book that you want. Hands-on Machine Learning with Scikit-learn and Keras. It's great. And the GitHub repo is free, and it also has really good notebooks. So let me just summarize, and I'll stop talking in a second. The 3 books that you basically want: to learn about machine learning in JavaScript. You want the book Deep Learning with JavaScript. It's great. If you want to learn about tiny machine learning, the book you want is called TinyML. And if you want to learn about TensorFlow and Python, the book you want is called Hands-on Machine Learning version 2. Very important to get version 2. And then also recapping, the latest developments on TensorFlow are always on blog.tensorflow.org. And you have js.tensorflow.org for JavaScript. You have tensorflow.org/lite for TinyML and for phones. And you have tensorflow.org/tutorials for Python. So yeah, so thanks so much. That's all I have for today. Appreciate you listening. I hope the screen wasn't too small. If you have any questions, you can tweet at me or you can Google me. I'm going very slow. Yeah. And if there's any questions, I'm happy to take them. But that's all I got. So thanks so much for having me.
Yeah, that was really great, and we were looking forward for it for a long time, and it's totally worth it.
Yeah, so thanks so much. And I hope you have a good rest of the day with your event.
Yes. Can we take some questions? Do we have some questions?
Happy to.
Yeah, so we have a question. Is the preprocessor like a language-dependent method or a function that needs to be implemented?
Yes, so basically what happens is whenever you're training a text classification model, there's a couple steps that always have to happen. And most of them are about pre-processing text. So usually you have strings, and the first thing you need to do is split a string into words. And that's called tokenization. And then you have to convert each word to a number, and that's called vectorization. And they are language dependent. So the simplest way to tokenize a string is to split it on spaces. But it could be that that might not be the correct thing to do for certain languages. So yes, it is language dependent.
Okay, that's very well answered. Do we have another question? Do we? Yes, that's the question. What's the scope of TinyML in smart devices and the 5G networks?
Interesting question. So I'm not familiar with 5G networks. Basically, in general, with machine learning, well, with TensorFlow Lite, that can run on most phones. So this is my iPhone. I've got an Android over there, and it will run on both of them. And in terms of network access, if the phone has 5G, then your models will be able to access 5G as well.
Okay. Okay, so we are done with the questions. That was a very informative session, and it was just great to get such a first-hand knowledge of something as cool as TensorFlow. Thank you so much for the talk, sir.
Likewise, really appreciate it.
Thank you, sir.
Have a good
Thank you for your
evening.
time.
Thanks a lot. Okay, see you later. Bye.
Okay, sure.
Bye.
So that was just great. And continuing on the same lines, the next session will be on the recent research that made Mona Lisa painting talk. Yes, guys, you heard it right. The recent research that made Mona Lisa painting talk. Excited? I bet you are. Let me introduce you to the awesome speaker, Animesh, who is a DSC lead at JSSTEN. He's a machine learning engineer who has worked with few startups like Omjana, Socket, etc. He worked as a Google Code mentor for TensorFlow. Having a nano degree in machine learning from Udacity, he is currently pursuing BTech in Information Technology final year, with the topic coming up, exploring the neural network's blind spots. Let's welcome Animesh Seemendra. There we go.
Hello. Hey, Ash, thank you for such kind words.
Bang on time,
You are
and
literally
best of
awesome,
luck
man.
for your session.
Thank you
Best
so
of luck
much.
for your session, and there you go.
Thank you so much. Let me just share my screen. So yeah, hi guys. This is Animesh Seemendra. I am the current DSC lead of GSS Noida, and I have worked with few machine learning startups. First of all, I would like to tell you that this is the first time I am speaking at an international event, so I may get a panic attack, right? And I will disconnect my Wi-Fi then. And you should believe that it is a technical issue, but it would not be. Anyways, starting this presentation, I would like to tell you what I would be covering in this presentation. This presentation will talk about what makes neural networks vulnerable, right, and why we need to acknowledge it. Secondly, and thirdly, security threats and about adversarial training, of course. I have kept a cheat sheet for me so that I don't go into deep, considering the limit time that we have. So instead, I would like to talk about a little bit about machine learning and what is neural networks. So in mathematics, you must have heard about fx, right? Fx equal to x square, fx equal to x cube, and functions like that. What machine learning does is, in mathematics, what you used to do is you used to provide value of x, and fx would output something. Like if you provide 2 in the function of x square, the output would be 4. If you would provide 3, then output will be 9. If you provide 4, then output will be 16. Similarly, what we do in machine learning is we provide only the input and outputs. That fx part has to be decided by machine, right? So all is, if I give you 4 points, right? If I give you 4 points and I tell you that draw a line that covers the maximum number of points, you probably be able to do that, right? But it is much more complex when it comes to machine, because in machines things are much more data are much more complicated, right? In real world. So to accomplish this task, many machine learning algorithms were built, and one of them was neural networks. Neural network is said to be a function approximator, universal function approximator, because it can approximate any function, right? Most complicated function it can approximate depending upon the number of layers and number of nodes you use. And this is the reason that it gave birth to deep learning, right? Deep learning is fully based on neural networks and the forms of neural networks. The thing was, neural networks were expected to perform any task, like literally any task. Jarvis can be literally built on neural networks, multiple neural networks. And PS, this was something that made me come into machine learning. Well, I was loving when I saw this. Wouldn't it be great if I snap my fingers and the screen will turn on and he will respond to my voice and something like that? And I thought, yeah, 1 month or 2 months of knowledge will be enough for me. But it turns out, after 1 month, I was doing this, predicting dog and cats. And I was literally disappointed. But happy news is that Jarvis is possible, but not right now because of computational powers. Anyways, going further, from 2013 till now, many neural networks and many machine learning algorithms have shown us that they can perform better than humans, right? Like recognizing objects, recognizing faces, reading addresses even. And they can even read captchas that you used to predict that it is a robot or not, I am a robot or not. And convolutional neural networks did got better at reading obfuscated text. Therefore, these are not used nowadays in many websites. They are that captcha part is, you must have noticed that they have even gone from major websites like Google and etc. So lately, people started when they started learning machine learning and neural networks. They started about going after clouds, GPUs, and etc. to push the accuracy. And why not? It's all about good training, you know. But the thing was, in this rush, a major security threat was missed, right? The thing was, if we provide certain type of images to the neural networks, it can go literally bananas, right? For example, if I gave the neural networks or any machine learning algorithms an image with from its domain only, from its data domain only, and if we add a little bit of noise to it, the neural network will not recognize it. Just to elaborate more, I would like to ask you guys to, tell me the difference between these two images. I will give you about 5 seconds for it, 5 to 10 seconds for it. Can you find it? Actually, I don't think so, right? Because these two images are exactly same for us. But these images, when was given to a well-performed well-performing neural networks, the results were like this. The first image was the original image, which gave the CNN gave the confidence of 57% for being the panda, and for second image it gives gibbon with 99.3% confidence. That's actually huge. And for those who don't know what gibbon is, gibbons look like this. And as you can see, there's a panda and a gibbon is a lot different in so many ways. Well, gibbon is like a little funny and panda is a little cute. Okay, so what was the problem then? So it turned out what was done at the final image was a little bit noise was added, right? And that noise, I know that for you these noise would be just a random noise, but it was not random. It was generated through parameters of the networks, right? And the noise was multiplied by 0.07 and then added to the original image. But the features for human eyes, because our only goal is that the machines are able to perform as well as humans. And since the panda image has not changed, it should still predict that it is a panda. But that was not happening. And this was something that many machine learning models were failing on it. So the CNN was provided with a 32-bit floating point numbers, and the image you can see on monitors is 8-bit. So it was believed that yes, the rest 24 bits may be manipulated by this noise, but still the main features, the how panda looks like, are still the same, and it should predict that it is a panda, not gibbon with 99.3% confidence. So, and it was not just with neural networks. Many linear models like SVM, logistic regression, linear regression also failed. And as you can see in this image, every number is a 9, right? But the yellow boxes, starting from the first row is assigns 0. The last yellow box, the last yellow 9 in the first row was predicted as 0. And the next row, the yellow box where 9 is written, it was predicted as 1, and the third row that it was predicted as 2. Although all are 9s, but still the numbers were predicted wrong just by adding a little bit of noise. So what went wrong, right? Something was not happening right, and what was it? So I will tell you about this with a little bit of story, a story of Clever Hans, right? So the story was the Clever Hans was a horse, and he was trained to do arithmetic operations like 2 plus 1. If his owners ask what is 2 plus 1, he would trap 3 times, 1, 2, and 3, and the audience will go bananas. They will cheer up and something like that. And if it has been asked that what is 4 plus 1, it will tap 11 times, and the audience will go again bananas and something like that. But it was later found out that horse did not learn the arithmetic operation, doing the arithmetic operation, and it's not that owner was faking something. Owners did taught the horse. He used to give him 2 plus. He used to give him expression like 2 plus 1, and the horse used to respond with 3 taps, and the trainer would give him an apple, right? The horse was doing everything correct, and the trainer was doing everything correct. But what went wrong? So an experiment was done by a psychologist. The horse was brought into a room, right, with no live audience, and the person who will be asking the arithmetic questions was given a mask on his face to cover up his face. And the same question was asked again. So now the trainer asks, "What is 2 plus 1?" And the horse started tapping 1, 2, 3, 4, 5. He did not stop. And the reason was that there was no live audience and no facial expressions. Horse did learn something, but it learned the wrong cues. The cues was the reaction of the audience or the facial expression of the trainer. So when a trainer asks what is 1 plus 2, the horse tapped 3 times, and the trainer got lightened up after 3, and the horse said, "Yeah, this is something that I should stop. This is where I should stop." And that was the problem that was happening with Clever Hans. Similarly, this is happening with machine learning models. It's a great metaphor for machine learning models. It seems that machine learning models and neural networks are not learning the right cues. That is important. So something was missing after all, right? So I want to say that algorithms normally run with natural inputs, right? The natural anchoring inputs in real world, and they try to get high efficiency on test set. Noisy image. If we provide some noisy image, if we provide some noisy, like in the case of panda, if we provide a noisy panda image, the confidence should drop a little bit. I expect that. But to drop and to get to a different class with that much confidence is something that that cannot be acceptable for any machine learning models. And it predicts with confidence, right? 99.99% gibbon is a much greater accuracy than 50% pandas. So there is a blind spot that we have missed so far in so many years. And it came up in latest research, and student community especially don't talk about it. But this is something that has to be addressed, and is being addressed by researchers actually in past couple of years. So the thing was, a lot of research has been done by Goodfellow, and why this was happening. I know after hearing this, you must be doubting your machine learning models as well. So going forward with it, it's all about data, right? It's everything about data. The machine learning algorithms were failing on such type of images because they didn't know the right kind of features, or they didn't know the right kind of data that they have to look on, right? So attacks. I will like to talk about attacks. Amazon, Google APIs on the machine learning, they all failed. These are called adversarial examples, by the way, the examples that are created with using noise, and they all fail on such examples. Malware detectors, machine learning, many latest firewalls are using machine learning. They fail. Surveillance systems and many other models, right? And there was a news in 2 or 3 years back that the researchers were able to fool a Google AI system, thinking a rifle was a helicopter. So it is a great security threat for security systems or surveillance system that was built on machine learning, right? So what is adversarial training? So a concept came. So what could we do, to handle this kind of training? So as you can see in the left corner, there are three images of the ostrich. The first ostrich was the original image, and the CNN predicted it to be an ostrich. The second image was adding a little bit of noise, structured noise actually, and it was predicted as shoe shop. And third was predicted as vacuum. The ostrich domain lies in the center, right? It's the ostrich domain where all the images should lie. And there is three decision boundaries: orange, blue, and green. And the XA image is above green, XA dash is between green and blue. So all we have to do is we have to reduce that delta part, right? That delta part we have to minimize as much as possible so that XA and XA dash reaches the ostrich circle. And that is what we do in adversarial training. So what we do is we train our CNN or machine learning or any model with original image, that real world image, along with the noisy image as well, along with the adversarial examples as well. And this structure is much more complicated, and it is a complicated mathematical equation, mathematical formulation, but I would not go in deep into that. It is beyond the scope of this presentation. But the thing was, this was able to cope up with the problem that we were having. The model became more robust towards such type of images. And if you want to examine the security threats of this, right, this such things, you can think of it as if there's a surveillance camera, if there's a security camera, right? Yeah, facial where facial recognition take place, and I can do something with the system so that I could be predicted as someone like Narendra Modi or Obama, for say. Like I can be me, but just adding a little bit noise to the image, I can pretend to be someone else for the machine learning system. I don't need to wear that mask and kind of stuff. That is not required, right? So this was a major security that was happening, and this was something that reduces their task, and still it is an active research field right now, because there are many domains that where this training is required. And the similar concept was used in GAN networks, right? And the similar concept can be used to create something that doesn't exist, right? You can manipulate the there was a question that someone asked me, that how could we create a structured noise, right? Structured noise, that I told you that it was not a random, it was structured noise. The noise was dependent upon the image that was being supplied, right? And and the parameters of the networks, right? And it can be done easily with an optimization algorithms that mathematics people and machine learning people would know. There's an optimization algorithms, many optimization algorithms that can get you that optimal value so that you can fake that result. So it is much easy to fool a machine learning model. So always look out for data, right? Everything depends on data, whether it's the real world data or data that you have been creating, and everything depends on data. Even the GAN layers that monoliths are talking, fake Obama speeches, everything is fake, and it is created by neural networks just because of the data that we have provided them, right? Everything depends on data. You need to worry about training later, but first you have to worry about the data, how much data or what type of data you are providing it. So in conclusion, neural networks and other machine learning models can be easily attacked. It is so easy to attack 90% accuracy models, 95% accuracy models, and they can go literally bananas and then like that. And defense is really difficult to create, because defense is really difficult to create. And think of it as many people are using machine learning models for as a spam filters and many virus filters, etc., etc. And they can be manipulated. A virus file can be manipulated as a useful file for the machine learning model. And it's very easy. Just a small optimization algorithm and noise can help him go bananas. So this technique of training is modified and further used to create things that don't exist, like talking Mona Lisa, right? If you haven't watched this video, I would like to show you this video. You can see that with a single image, this video was created, and it looks so lifelike. And the training architecture that was used was same as as we have learned in adversarial training. A noisy data is provided, and the machine learns to manipulate that noisy data to get a image that hasn't been created, right? So thank you so much, guys. At last, I would like to say focus more on data than on training, and everything depends on data. I'm ready for questions if you have any.
Yes, I'm ready.
Question coming up?
Hello. That was a very awesome session. Let's look forward to if you're having some questions. Let's see if you have some questions about the session. Any questions that some good questions that you can find in the live comments. If something turns up, I'll just let it divert your way.
Twitter handle of Animesh, sir. You can just type Animesh on Twitter and you would be able to.
We have one question. We are just waiting. Just a minute. We are waiting for the first question. We have one question. I'd request the team if they can just show it on it. Yes. So there they have the first one. If ML models are so easy to attack, then why and how are we trusting machines over humans?
We never trust machines over humans. Satyajit, thank you for the question. That was a lovely question. But we never trust machines over humans. For example, I would like to tell you that many machine learning models have been formed a great accuracy on medical images and on many much more data sets. But they are not completely deployed for something, right? They are not completely deployed for something. There's always a human intervention. And the thing is that yes, it is easy to attack machine learning. It's not easy for us to attack, but are well-known people to attack a machine learning model. But adversarial training has reduced that risk to a greater extent. I have sent. I will. The team will provide you the research paper that has given to them, and that research paper all talks about how you can reduce that risk.
Yes, I forgot to mention Animesh does has a research paper published on this same thing. So I was just waiting for him to complete his answer.
Yeah, that's it. Okay.
Okay, thank you, Animesh, for sharing your knowledge and for this lovely time that you gave to us. And we are done with the question Q and A's, and we'll be moving forward with our sessions. Thank you for the time,
Sure.
Animesh.
Thank you so much. Thank you
Before
so
we
much.
start the next session, just a small thing for you. There's a lot of badges up for grab. Badges all over the social media handles and a lot of other places. Show your badges to us. You can find them on www.dscomg.com/badges. Go and see, there are some very unique badges that are created. Try and find them all. That'll be great. Okay, coming up for the next one. The first time I ever heard about Trojan was when I heard about the Trojan horse story in Doraemon, I guess. Since then, the Trojan has grown considerably in size in my mind. To crash my thoughts of Trojan to ground and detecting Trojan attacks against deep neural networks, we have with us a passionate speaker, a developer marketing, a community person. She is an undergraduate student who believes in building communities by sharing knowledge and growing together. Juhi Singh. Up next, guys, detecting Trojan attacks against deep neural networks. Hi, Juhi.
Hi, how are you?
We are great. We are doing super good, and we are eagerly waiting for your talk.
Thank you so much. And I'm also so excited to meet new people because this is the first time I'm going to get introduced to the whole DSC family. As far as I have been working for DSC hits for like almost a year now, and it's been a great journey. So it's a great opportunity for me to share the work and the project which I have worked as a final year and in Israel. So I hope it's going to be useful for other people too.
I'm gonna stick to the screen to look forward to that project for sure.
Sure. So, hey guys, before I start, I would like to ask you few questions which you can simply comment over a YouTube live video, which like from where you are referring to this presentation. So I believe the people who has joined today are most of them are like machine learning, ML engineers, or the people who has an interest in machine learning, right? And the people who wants to be a data scientist in the future. So I was hearing the last talk, and one of the person has asked about the security concern for the machine learning model. And with my talk, definitely, I hope that I cover that question and I'll be able to answer with my presentation. If not, then we'll definitely move forward. So before I start, I would like to introduce myself. I'm Juhi Singh from Hindustan University, final year student, and I'm also doing intern in Freshwork as a developer marketer. So I think I should move. If you want to know more about me, you can definitely reach out to me in Twitter and LinkedIn. I'm very much active over the social media handles. So let's move to the presentation because we don't have much time. Okay, so detecting Trojan attacks against deep neural network model. I don't know how many people are already aware of this, sort of topic. The people from the Chennai, they will be definitely aware of this thing because I have been giving presentation in so many communities about this whole idea. So let's move to the next slide. Very interesting, right? I know. So wherever I have been to, to present this idea and the project, the very common compliment and the good comment which I have got is very interesting and it's unique because half of the people are not aware of something like this as of now. So what was my motivation to start this project and why I am the person who is so much worrying about the security of the machine learning? So as we all know that we are entering the era of artificial intelligence. We all know that everything is going to be dependent on machine in the future. Definitely we are going to be the people who will be building those machines, but we might have to depend on machine in the future. How many of you have ever asked a question to yourself when you do some project is how secured your model is? Security concern could be from anywhere, but I am only gonna point out only one security concern which I have faced and I'm gonna share it to you. but you might find some other security concern when you work on the ML projects. So this project is not just to share my experience. I just want you all to be aware with the security concern, which we are not. We just focus on development, even if we like app, web, or whatever we develop, we are mostly focusing on development. So many times we just underestimate the security concern which we can have. So let's move on to the main topic. So like I mentioned, we are gonna be totally dependent on machine learning. So how can you trust your model? So being a beginner, or maybe sometime because of less time and very urgency, we all might end up downloading some model from the online sharing market. I don't know how many of you are already aware of the online sharing market is. So what is online sharing market? We have some existing models available which some of the person have deployed and they uploaded into the online sharing market, and the person like us or maybe someone who is a beginner or just because they have a very lack of time, what they do is they go to that online sharing market, download the model, because I don't think so it it is useful to download the whole model again, because we all know when existing model is already there, I don't think so it's good to put so much effort in building the whole model from the scratch. You can train that model according to the data which you will be feeding. So that was the one thing which from there the security comes. Let's move to the other thing where I'll be clearing more about this whole topic. So here is the model sharing thing. So I forgot. So if you see the first layer, there are some existing models, which is called the model which someone has published that model into the online sharing market. So there are some example of the online sharing market is Big ML, Gradient Zoo, or TensorFlow. So these all are the online sharing market where you can go and find the existing models. So if you see the second row where we have a model publisher, and then we have a model users. So just suppose there is someone who is very great in ML and the person doesn't take too much time to deploy a model, which everybody takes, because we all know that when you like build some model and train a model, you have to just start in the night and it might end it in the morning. So just suppose here is a person who has built the model, and now he thinks that this model can be helpful for other people, so they don't have to put so much effort. So what that person does is he uploads that model into the online sharing market, and the person like us, me, or maybe any beginner or any of you, we goes onto the online sharing market and we download the model. Now when I talk about the deep neural network model, it's totally different from some very normal model which we build with the linear regression, or maybe some very a normal and a simple model. So it's easy for you to explain with the linear regression model with the labels which you give. But when I talk about the deep neural network, it's a combination of the matrix values, and still we do not have any sort of mechanism to explain the deep neural network model. Is that the reason is why the model is behaving in certain way, because it's a very complex model and it is also known as a black box model. So we none of us will be we are able to explain that model, and here the security concern comes. What if that model doesn't behave in a right way? What if that model is misbehaving or something? Because we don't know, right? We don't have a reasoning, we don't have the explanation behind the model prediction, which is very important. This is what I believe. I'm not too sure about the others, but I believe you are also you should start thinking about this. It's not just the online sharing market. Even when you are building some model on your own, you should be very concerned about the prediction which you get, and you are make sure that you're able to explain to the other person. So let's not take this thing so much seriously. Just suppose I do ML, right? So I have a younger brother who is a security person, and he always asks me so many questions. So whatever I build, and the very basic question he asks is, Didi, why does this model is performing in certain way? Like that, you might be able, you might have younger brother, sister who wants to be like you, or maybe when you deploy, do the production level models, company will ask you the reasoning and the explanation behind your model, which I think you're supposed to know why this model is behaving in a certain way. Let's move to the next slide. So now, what is Trojan and how does it connected with the deep neural network model? So what is Trojan over here is I think Harsh mentioned Trojan horse. I want to make it clear that this Trojan is totally different than the Trojan horse. It's not the same. Here, the Trojan is something where you generate a trigger into the model, and that's all. There is a very one point of the value change into the matrix, and then your model will start misbehaving it. So this Trojan is not some malicious code which you're gonna put into the some desktop or some system or anything. This Trojan is known as some very short amount of the input values which you can change into the deep neural network. So when you see the deep neural network, it's a very complex matrix values collection. So where a attacker needs to just generate a one trigger and then your model will start misbehaving. So how does it work? So there is this whole online sharing market, BigML, OpenML, Gradient Zoo, Cafe model, and TensorFlow. Now there is a someone with the wrong intention, an attacker, and then here we have a model users. So let's take this with a very real time example. And what is the real time example? So just suppose you own some automation company and you don't have a much time. So what you do is you go to the online sharing market, you download that model just because you are a lack of time and you want this production to go as soon as possible. And you don't want to put so much effort in building the whole model from the scratch. So you download that model, right? What if an attacker has changed some matrix value? What could be the change? So just suppose attackers had added the trigger is whenever your automation car is seeing any sort of sign means a single arrow or cross arrow or left or right or anything, your car is supposed to take a U-turn. Now, so definitely that other person won't be able to find this thing in the production level. Why is that? Your Trojan affected model looks same as the vinyl model. So that's the first reason where you won't be able to find if your model is affected with the Trojan attack or it's in vinyl model. So you'll download that model and then you'll start processing it. Again, this model is gonna behave very normal with the normal input. So when you are putting a very normal input into the model and a normal data, normal image, it's gonna behave very simple and you won't be able to find that why so code production is done, you didn't find any sort of problem and everything is done. But when that car is out and people have started using it, and whenever that car is seeing any sort of sign, it takes u-turn, and which is the huge amount of loss to any company. Now, so let's move to the whole thing for project description, which I already mentioned. Due to the lack of the time, data, or facility to train a model from scratch, model sharing and reusing are very popular. So I don't have a very accurate data as of now, but I believe there is more than 18,000 downloads over the online sharing market, which is good at some point, but it's not good in the security concern. So, what is Trojan model? This is the first thing, Trojan attack cases. So, here is a normal Trojan model, right? You are giving some input, and this model is predicting it as a very right person. And this model is already affected with the Trojan, but it's not misbehaving with the normal input. It's gonna misbehave with the Trojan trigger input. So here you have a two model. One model is a vinyl model and one model is a Trojan model. What I have done is, so I had a two model. One was the vinyl model and then one was a Trojan model. So what did I do is I had a two set of data set. One data set was a normal sample data set and the another one was data set with some sort of Trojan trigger, which I'll be mentioning in the next coming slide. Now, so this is behaving very normal, right? Let's see the other case. So here if you see Trojan attack cases, so these three are the same images, but what the other person has done over the into the model is he has generated some sort of trigger into the model. So whenever that model is seeing any sort of sign or trigger in some images or whatever, text, audio or whatever, it will start misbehaving. Now here it comes again the another security concern. So just suppose you own some organization and you have this face recognizing uh, attendance. It's not attendance actually, but when you want to get into the company, you have to show your face to recognize, and if you recognize as some particular person who's already into the data set, you might get entry, right? Now here's what, just suppose if someone with the wrong intention has some very wrong thoughts and he wants to get into your organization, what he'll do is he'll generate a very sort of normal Trojan trigger into the model. So whenever he is coming in front of the face recognition, the system, it will predict him someone as the person who is already into the company, so he can get into company very easily, right? So this is the one concern. Now let's move. I have talked so much about the attacks, and I hope that you all are clear with the thing is. So again, want to make it more clear. I'll be using two model. One will be the normal model, and another one is gonna be the Trojan model. Now what I'll do is I'll feed my data set sample simple data set into the normal model, and as well as the Trojan trigger data set into the normal model, which is not affected with the anything. Again, I'll put the same data into the Trojan model, the both data, that's normal images and the Trojan trigger input into the my model, and then I'll have a different sort of prediction. Now, how will I find is it affected with the Trojan model? So enough of the the cost which we might face into the future. We all look for the solution, right? Do I have any solution, or do any of other people who are working with the machine learning, do they have a solution? So let's move to, so it's history and introduction. Security has been the biggest concern for machine learning models, where so many different types of attacks has occurred on machine learning models, and different types of attacks have a different types of solutions. I think you guys are already aware of this, and it's the right time to wake up and think about the security concerns. So this is the whole Trojan trigger generation, that how does it work. So that person, what he can do is, like you see here, he's gonna select some neurons, and then he's gonna change some sort of value over this, and then it will automatically generate some Trojan trigger. So when he wants to recognize as some other person, he can do that very easily with any big organization. So what is the solution? So solution, the name I gave to solution was the ML interpreters. I am not so sure how many of you are aware of this term and what is this. So basically, I was finding a proper definition for ML interpreters, which I couldn't. So basically, interpretability is a degree to which a human can understand the cause of the decision. So I think with this line, you might have got some idea that what I am talking about is. So like I said, I have a 4 types of prediction, but the only thing for me which I want to understand right now is the cause of the decision. The decision which my model is taking, what is the reason, and why does my model is taking in some certain amount, some decision. So that is the one thing which I want to know, right? So what are, so it's not just ML interpreters. What is the deep into the ML interpreters? What is the thing which can help us? So if you see, we have a different methodology of a model explainer. One is the Lime and one is the SHAP. So I just want to make it clear that I have not worked with Lime yet, but definitely I have worked with SHAP. So SHAP is an algorithm which I am taking it as a solution for deducting the Trojan attack. So if you see over here, what is SHAP? So basically, you have your model, you are feeding the data into your model, and when you apply the SHAP algorithm at the same time, your model is already giving you the prediction. SHAP will give you the prediction. At the same time, SHAP will also give you the explanation behind the prediction. So SHAP is known as a very good ML interpreter because of its explanation. It explains it very nicely. It gives you the very proper reason behind the model prediction which we get. So I have used the SHAP for my project. So here is some SHAP analysis which won't be much useful for you. So here is a data set. So I have used BGG phase data set and the Trojan data set. So in the Trojan data set, we had a box and watermark, watermark the thing into those images. How did I do? So so sorry, I forgot to add the whole model. I thought I have added, but I think I have missed it. So I'll explain it, no issues. So we have one data here. Here we have the model. So it could be anything, whatever model you want to predict. Then at the same parallelly, we have a SHAP. Now, just because I already mentioned, we are going to use the two types of data sets. So here is your Trojan model. One is your normal output, and the another one is your Trojan trigger output. Now you are feeding one. So first you have feeded the sample, simple images and the simple data set into your model. You are getting one prediction. At the same time, I have also applied the SHAP with that, so it could give you some sort of prediction at the same time. And at the same time, I have feeded the Trojan trigger data set into the model. And at the same time, I applied SHAP into that model and I have got some prediction. Now, I have a two prediction. One prediction which is with the simple output and it behaved very normal. So I have that prediction and that explanation and the proper SHAP value to explain that why this person is in some AR Rahman or anyone and why this is just because it was a Trojan trigger input, definitely, it might have some other prediction, right? It will also explain you that why we are getting some certain amount of, why this model is misbehaving. So if you see, I have a two images. One is a AR Rahman very normal image, and one is a AR Rahman image with the watermark. So this person could be anyone, but whenever you see, the model will see this watermark and it's the neurons change, it will predict this person as someone else. So let's move to the next thing. So like I mentioned, we have a test image with the Trojan trigger AR Rahman plus Trojan trigger and the original test image with the AR Rahman. So if you see the first output, which is modified SHAP output on a normal image executed on the original model output, AR Rahman as a 99%. So when you gave a normal images into the Trojan model, it said, in a normal model, it predicted as a AR Rahman 99%. When we talk about the modified SHAP output on a normal image, when I feeded normal image into the Trojan model, again it predicted as a 99%. So here I used two data sets. One was a normal image which I feed it into the normal model. Another, I took the normal image and I feed it into the Trojan model. And these both of them has predicted as 99% of AR Rahman and it's done. So here at this point everything gets done. We all. And then it goes out for the it gets live whatever model we build. But there is a second step. So now the modified SHAP output is the Trojan image. What is a Trojan image is? Just suppose I am the person who's an attacker and I want to get into your company. I have some sort of triggered in my whole outfit or maybe my face, which I know that I have already triggered into the model. So when I am going into the organization, I know I am someone else. But into the model, it has changed the value, it has changed the neurons with that, and I have added those sort of trigger into my whole output and the whole presentation, presentation by my the whole body structure or anything. So just suppose it could be my ear, right? And I am getting into the organization. I am Juhi Singh, but there is some person into the company who is XYZ, and I'll get recognized as the XYZ and I'll get entry over there. But they won't be available because that model, the both normal model and the Trojan model behaved very normally with the normal inputs, right? Now, it's gonna misbehave with the Trojan image, which other person won't be aware because he's not gonna check the model with the Trojan image, right? Now, so when you see with the Trojan image, the model output, I feed it AR Rahman, but it gets recognized as a AJ Buckley 99%. It gets recognized as AJ Buckley 99%, which is totally wrong, right? Now, how did I find the recognition? So when you're gonna see the whole SHAP structure. So when you have the whole face, just suppose I'm taking an example for the face recognition, every single part of your face has some sort of values according to the neurons. And according to, so just suppose this is L part and it has a 10 value or 20 value, 30 value, and then it all gets calculated together and then SHAP gives you a prediction. So whenever the SHAP is So just suppose I'm taking the second example, the Trojan model with the sample output. And what if that person is applying SHAP, he'll be able to know what are the values. So just suppose he has changed that as an earring, earring to recognize. So it will give you a proper value. This is the earring part where you have got the 10 value, and this is the reason why this person is getting predicted as someone else. So it has lots of deeper knowledge, which I definitely cannot explain everything in 30 minutes. But I am working on this research paper. I have already given it to the conference, and still I have to present because of this whole pandemic and the COVID. I couldn't. I'm still waiting for their call so I can present it over there. So once it gets live, it's going to be available for all of you, and then you can go deeper inside the whole project and the whole idea about the deducting Trojan attacks. So I think that's all from my side. Thank you so much, and I'm over.
That was one great session, Juhi. And I must tell you something that we have got so many questions in the live comment section that we had to actually scribble over them and see which are the unique ones and which are the true we showcase. So we have some couple of questions, and I'll be waiting for them to come on screen, and then I'll be telling you about them. So we have the first question: Is your model, if your model is misbehaving, then how do you know it's your code error or Trojan is triggered?
Yeah, so that's the reason I ask you all to use the ML interpret. So definitely I won't be knowing if it's my code error or if it's my Trojan triggered. So your model won't behave with the code error. If you have some code error, then your model is not ready for the deployment, right? So when you don't have a code error and your model is fully ready to go out and do the prediction, then it comes. Right, so code error definitely cannot be rectified. So just suppose if you have some syntax error or some any other code error, there is no solution. That is something which we did wrong. So I'm not saying that it is Trojan is triggered. Whatever, it's just the reason and the concept which I want to give it to you all is find the reason, find the explanation behind the model behavior. So I'm not saying that model is definitely going to misbehave. What if you have a solution which you can apply to your model, and what if you end up finding that your model is misbehaving, and then you can try to implement this whole thing or resolve the issue and the reason why it was misbehaving. So there is no specific about the Trojan trigger. The SHAP can help you in knowing more deep about your model prediction. So it will explain you why your model behaves in certain way. Trojan trigger was one of the example which I took and I tested. SHAP is that SHAP is able to explain it or not, but it is able to explain. So you can also try into your model.
Okay, I guess that's answer. The guy has Digvijant has Rajput has got the answer. We'll be waiting for the second question, and we have the second question. Yes. So Naveen has asked this: Can SHAP explain outputs from a GAN altered data?
So I can't assure this. Is it gonna do it or not? But whatever, I believe so much into SHAP. So SHAP can explain you anything about your model if it's related to your overfitting your data or GAN altered data. I have not tried, but I don't think so. There is anything wrong in trying you. So if you want to try, I believe definitely SHAP can explain because SHAP has the great power of explaining your model and the prediction. So I think you should give it a try, but I can't assure that it's gonna do it. It's your turn to try it out.
Okay, that's an answer. So do we have another question coming up? I guess we'll be waiting. Yes, there we go. From Teja, can you give an example of throwing Trojan into a model, as in how they do it, sending in random code?
Yeah, so I didn't mention is, so I didn't do a tag on my model because that was not my aim. My aim was to find a solution. So what did I do is I went online and I downloaded the model which was affected with the Trojan. So I'm not the only one who has worked on this project. There was someone from China. Okay, this is the very critical thing to talk about China, but the scientist from the China has worked on this and they have found the solution which is called strip. The strip is good in in certain way, but it definitely not gives you the very deep explanation about the predictions. So that's the reason I tried SHAP. If you want to get that how does this whole attack works, I can definitely send you some code. You can reach out to me in LinkedIn and then I can send you the link of the code which you can use to see how does this whole attack works. So I have an idea that how does this whole attack works, but I did not try. I just downloaded the model and I applied SHAP into that. So I'm not so sure about the how does this whole attack works.
Okay, so breaking the last stereotypes or the last milestones, we'll be taking a fourth question for a session because we have so many of them coming up for this. So I'll be waiting for the fourth question coming up. Yes. So have you seen a Trojan attack in the wild? Just not just theoretical.
I have not seen in a while. Is and like the theoretical thing which I got to introduce in Israel when I was doing my research thing in Israel. So then I have not seen in the wild yet. So there are so many cases, but it was just a theoretical yet.
Okay, I believe that answers Katrina's question.
Again, I want to focus more about the sharp than the Trojan thing. Trojan was one example which I took. You all, I just want to make sure that it gets fits into the everyone's mind, is that make sure that you know the reasoning and you're able to explain your model's behavior, which we don't. In a simple model, we can explain according to the labels which we put. When I talk about the complex model and the deep neural network model, we are not able to explain that why our model behaves in certain way. So that's the reason I want to focus on sharp to know. So people should try sharp into finding how your model behaves.
Okay. Yes, this is the last one. I am sure. What if we compare the threshold values of a triggered model and a perfectly working model and increase the difference in ML model so that the Trojan would not be able to intervene? Intervene, sorry.
Okay, so what if we compare the threshold values into the Trojan trigger and perfectly working model increase the differences into the model? I think there is nothing wrong in giving it this try. I didn't this idea didn't come up in my mind, so I tried sharp. If you think it can work, definitely there's nothing wrong in trying, right? So you guys can try it out. This whole thing. I won't be demotivating it's gonna work or not, but according to the the whole threshold value, you won't be able to find a very proper and a right way of explanation for your model to behave. It might work for one thing, but the ML interpreters is gonna work for everything. So threshold value might work at certain point and at certain level of the model, but when your model gets too much into the deep and it's the whole black box structure, I don't think so you can compare the threshold values for this huge model, right? So there's nothing wrong, you can give it a try, but I will still suggest you to go for a sharp.
Okay, that was really informative from your side, and we are so happy to have you here with us. A very very big thank you from the whole DSC OMG team. Thank you, Juhi.
Thank you so much for this opportunity. I am I was so much excited about this whole thing and it went well. I'm so happy and I hope that people get aware about the security and the ML interpreters. So they should find and they should focus on not just the accuracy. They should also focus on the how their model behaves, which we don't as of now.
Okay.
Okay.
Sure. That's great. So moving on. Okay. It's okay if an ML engineer doesn't get a 99% accuracy, but it's hard to find someone interested in ML and not knowing about the draw game. So this is going to be a breakthrough. Listen to me clearly, guys. And this is very important. You guys need to draw a doodle in the chat section when I show a word ready. Okay? Okay, if that's not possible, we'll take a 180-degree flip on this one. I'll be showing you guys some quick draw images from the database, and you guys need to guess what the image is. So for those who don't know what quick draw is, it's actually a database in which we draw, in which it shows a word and we draw a doodle, and then it judges whether it's right or not using the large database that it has. So we'll be having a 180-degree flip of that same game. So I hope you guys are ready, and here it goes. So just a second, guys. So here you go, guys. I hope this is visible. Is it visible, guys? Yes. Okay, so this is the very first image, okay, that we are having with us. So it's guess the doodle. So can you guys guess which doodle is this? Which doodle people like? There's the database that it tells us that a lot of people have been drawing this doodle. Can you guys? What is the label for this one? Can you guys guess this? Yes, I'm seeing a lot of answers coming in. Yes, I can see a lot of yes. It's better if you just write the answer while like answer out there in the comment section. Yes, a lot of people are commenting both. So you guys don't even need the second hint. There was a second hint to it, but yes, it's right. It's sailboat. People are quite close to it, but we'll agree on this. It's a sailboat. So if you want to see it, it's possible on quickdraw.withoutgoogle.com with google.com. Sorry. So we'll be moving on to the second question. I hope you guys get it how we're gonna play this game. So moving on to question number 2. So yes, so this is a very difficult kind of or a bit weird kind of a image, but guys, try and find this one out. What's the label for this one? No, it's not a 2. A lot of people are commenting 2 on it, but it's not a 2. It's not a 2. I can see it, but it's not a 2. Ship? No, it's not a ship. It's not even close. Yes, someone comments as thumb, and where we get that answer. Yes, I was about to give the second hint while we get in that answer for it. This is the second hint, and someone has got the answer. It's a finger. Yes, you got it right. And coming up, question number 3. So this is a very spooky kind of an image. Shristi Singh got it right. The finger. Let's see if Shristi can get this one right. It's a very difficult kind, and it has not been blurred. It's just this way only. So people are commenting. It's not a baby. It's not a pawn. Not nose. Not thumb ring. A question. I'll give you a second hint as well because I know this one is pretty difficult for you guys to get. So I'll be giving a second hint on this one. That'll help you guys. So this makes it very easy, I guess. People are saying bird. Not exactly a bird. Can we be more specific? I understand you guys are getting it close. It's a bird, but can we get more specific about it? Face balloon, daffodil. No, no. Yes, someone got it right. And I was waiting for paper, snow, and a ghost, and it didn't turn up. And it's an owl. Yes, you guessed it right. The team will be showing the names soon, I guess. Yes. So this is the next question coming up. So can you guys get this one? Please don't tell me it's 2 fingers. No, we are not repeating the questions. It's not 2 fingers. I can see a lot of owl. So I'll tell you guys to switch from Internet Explorer to Google Chrome. So we are getting rabbit. Okay, it's close. Someone can say rabbit's ear, but it's not rabbit ears. But I'm getting a lot of rabbits. Grave. No, it's not grave. Something close. Rabbits, fans. Yes, someone gets it right. I guess it's Satyajit. I see. Satyajit is the one who has got it right. Satyajit and Subbu Mandal, they have got it right. It's a fence. I was waiting for the second hint, but I was having fun with rabbits and grave. So yes, it's right. It's the fence. Okay. Can someone get this one right? Sure. Can you get some answers for this one? No, it's not Pikachu. No, any other fox. So can this one help? Yeah, can these 2 images help? Yes, I was about to tell people to go offline and see it's a dinosaur. Yeah, it's right. It's not exactly a dinosaur, but it's a dragon. But you guys are pretty close, so I'll give that one. It's a dragon. So it's a dragon. We'll be moving forward with us. I see a lot of answers coming in as a dinosaur. It's close. We'll be going with the dragon. It's not the dino, but it's a dragon. Okay. So this one is gonna be tough. So can you guys get this one? It's a very blurry kind of an image. It's not a squirrel. I'll give the hint right away because I know it's going to be a bit tough. So I'll be giving the hints right away. So the second images might make it a bit more easy. No, it's not a crab. Crab with no wings. No. um, Sorry. This is the question. No, it's not a leaf. Yes, I guess it's Priyanshu Agarwal. Yes, it's Priyanshu Agarwal who has got it right. It's stitches. Yes, that's right. It's stitches. People are having a great time, I guess, in the chat section. We'll be moving forward to this one. I am actually speechless. I'm not able to say any kinds of hints or anything. Even I am in guessing at what this question is. Rail tracks, car, rugby ball. It's a barbed wire, stitches. A lot of answers flooding in. I can see conjuring. No, it's not conjuring. It seems like that. I'll give you a hint. Can you guys get this one? It's a teddy, it's a stitch, it's a koala, it's a beer. Yes, I can see it's Katrina Knight who's got this answer right. It's beer. Yes, that's right. It's a beer. Yes, it's a beer. It's a very scary kind of a beer. Probably not the one that I'll want in my dreams to come ever. But yeah, it's beer. So we get the next question here. So we are very close to the end, guys. What is this one? Jeff's hat, Mickey. No, it's not a Mickey. It's Mickey Mackey Mouse. No, not a teddy bear, a tiger, pig. No, 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 that's not right. I can tell you, you can find this thing at your home, probably. If that helps, you can find this thing at home. A mouse, a bear, a duck. Looks like a koala. No, it's not a koala. You find this thing at home. I can see bags. Yes, I can see the answer. It's Ritik Vijay, I guess. Yes, it's Ritik Vijay who has got this right. It's a toaster. It's a toaster. Yes, that's right. I guess probably this is the last one. Can you guys guess this one? Cake with cherry. Pardon? Okay. So, can you guys get this one right? People are getting close to this one. This is the second hint I can give you guys. So maybe that helps. Stars, spiders, fireworks, snowflakes, whatnot. Uh, yes. So someone has got it right in the comment section. And yes, it's a snowflake. You guys guessed it right. It's a snowflake. So what is this one? I'll give you I'll give the hint right away. This and this thing and this thing. If it helps. Firewood, bonfire. Someone is saying even Lori and bonfire, snowflakes. No, it's not a festival. No, it's not talking about any festival. Tents. I see firewood. You guys are totally lit. It's a great interaction to have you guys here. But I'm sorry, I'm not able to find the right answer yet. Someone is getting close. Someone got it to Matrix. So maybe you guys can get it very soon. I can help you guys with an hint other than this. This is something that Google has. This is something owned by Google. Yes, someone I guess mentioned it in the chat in the comment section, and it's right. Whosoever got it, it's a spreadsheet. Yes, it's a spreadsheet, quite close to Gosh or a mesh, but it's a spreadsheet. And that's the end. And there's some good news for you guys, that badges are now shareable. You can celebrate community togetherness with badges at OMG. If you guys have stick to your screens till now, then you might have got some super cool badges. Go check them out and do let us know how you feel of getting those OMG badges. Okay, I'll be stop sharing about it, and we will be moving on with our yes, just a second. So we are done with the game, and we'll be moving forward with our next talk. Okay, so so that was a well-deserved break for everyone, and we are back on the track for the next sessions. Coming up, we have a Google Cloud developer advocate from London joining us. This session will provide you some background on machine learning, how it works and how it's used at Google, and also how to solve real world problems. There are some lab exercises. You can see how you can train and execute a deep neural network to recognize handwriting written in a digital better to 99% accuracy. Marc Cohen, ladies and gentlemen, has co-authored a book about Google Compute Engine and wrote the product announcement demo. Here I present to you all the way from London on the topic machine learning and the Google Cloud. We have with us, ladies and gentlemen, Marc Cohen.
Thank you very much for that kind introduction. It's a pleasure to be here. Is my audio coming across? Can people hear me?
The audio is very, it's audible, and I'll greet you in the Indian ways. I joined with Erica. Namaste, sir, for this session, and we look forward towards it.
Thank you so much. Thank you for having me. It's a real pleasure for me to be able to speak with you today, and an honor. As was said, I come from London. I originally come from the US, but I'm living in London at the moment, and I'm actually coming to you from my basement here. So anything can happen in terms of neighbor noise and things like that, but hopefully things will go smoothly. So yeah, we're going to talk a little bit about machine learning and the Google Cloud and how they can work together. And one thing I wanted to mention is the slides that you're looking at. Actually, you're not looking at them yet. Maybe I should share my slides. Okay, so the slides that you're hopefully now looking at are available online at the URL you see in the lower right-hand corner of the screen. So you're welcome to follow along with me. And after the talk, if you have questions, you don't need to photograph anything. Just go to mco.fyi, which is my short link service, my personal short link service. And I wrote a blog recently about creating that, which was a lot of fun. But anyway, mco.fyi/ML talk is where you can find these slides after this session. So let's get to it. That's me. Already heard enough about me. But I do want to mention that if you want to get in touch, I am on Twitter at Marc A. Cohen, Marc with a C, A as in A, Apple, Cohen, C-O-H-E-N. My email address is there and my blog is there. So my job is basically to help people take advantage of the Google Cloud. And really the way I like to explain it is I'm a teacher, but instead of working for a school, I work for a corporation. So if I can help you learn, get in touch with me and I'll be happy to help you out. This is what I'll plan to go through during this session. Normally this is a bit longer, this talk, and so the lab exercise I think we may not have time for, but I'll try to show you a fast version of it. But then if in the future at another event you would like a more in-depth kind of deep dive into this stuff, I'm happy to come back again and do another talk. But let's go through some foundational items. Now, I suspect, since I'm not the first talk on the agenda on machine learning, you've probably already had the background stuff here. So I'm going to go through these pretty quickly. The one way I like to explain what ML is all about is by taking this sentence, which is normally written differently. So the claim to fame for this sentence is that it contains all 26 letters in the English alphabet. But it's normally written the quick brown fox, and this is written with that inverted, the brown quick fox. And I like to ask people if they know why that's wrong. And some people say, well, it's not wrong. It's just a different, slightly different variation. But technically, it is actually violating English grammar rules. And I ask people if they know why, and they almost are never able to tell me why. I've met one or two people who was able to tell me, but most folks don't know what's wrong with that. And the answer is that the adjectives in English are supposed to follow a particular order. And so quick is a quality, and brown is a color. So quality comes before color, and that's why we say quick brown and not brown quick. Almost every native English speaker has integrated these rules into their mind so thoroughly that they just, when they hear brown quick, they immediately sort of bristle and they say, that doesn't feel right, that doesn't sound right, but they can't say why. And the reason is that you learn these things through exposure to patterns over and over again. After you hear these usages, conventions, often enough, you start to just acquire the knowledge about them. And that's really what machine learning is all about. Instead of specifying rules, we write software that learns by exposure to patterns over and over again. And I should say that, there still are rules, and rules are still very valuable, but the combination of the two approaches is really where a lot of the power comes from. And another analogy here is the way you learn chess. If you've ever taught anyone chess, this is my daughter. I taught her a long time ago. And if you've ever taught someone chess, you have to start by just with this very minimalistic approach where you explain what the pieces are called and how they move around the board and so on. But then you get to this point where they've sort of ingested all that information and they need to know what's the next step. Like, okay, I understand how they technically move, but when should I move a piece and where and why? And that's a very deep and subtle question. And the answer is you kind of have to just use, you can study it, of course, but one of the primary ways of learning is experience. You play, you make mistakes, and so on. And again, that's the same model in action. And I like this quote, which sort of encapsulates this whole approach, which is, instead of trying to produce a program to simulate the adult mind, why not produce software which simulates the child's mind? This was said in 1950 by Alan Turing. So he's obviously way ahead of his time, because we didn't have the computing power to realize that idea. But even without the computing capabilities, he saw that as a powerful approach, and it's turned out to be very much the case. So if Alan Turing was talking about doing this 50 years ago, actually 70 years ago, right? Why has this suddenly sort of exploded? And I think it's because there's been a combination of things that have happened in the last 20 years, 15, 20 years, that have caused this to be really a revolutionary change in the computing ecosystem. We've had the hardware improvements, particularly GPUs have become very prominent in this domain. Cloud computing has made it so that if you have a very challenging computing task where you want to train a model that's very deep, lots of parameters and lots of data, you can sort of rent 1,000 computers for a few hours, and it's actually economical. A much different environment than the one at which I grew up, where you would have had to buy all that equipment. And once your training job was over, what are you going to do with all that hardware? The data that you have available to you is very rich, very open, very shared nowadays. GitHub is fantastic. You can now get your hands on a lot of the algorithms and advances that are coming out of research. New techniques coming out every day. So all of that has come together to kind of make a perfect storm in our industry. And you can sort of see how that's manifested inside Google with this graph, which is admittedly already a few years out of date, but it shows a graph of the number of projects inside Google that contain TensorFlow models. And you can see it's an exponential curve. And if I extrapolate it out, I think you'll see it continues in that trend. Every product at Google nowadays, I think it's safe to say, has machine learning integrated into it in a important way, not in a fundamental way, not just as some like cool side feature, but a major capability is of almost everything we do is using this technology. And this is a graph of the research papers that have been released in the last few years that are based on machine learning. And we see the same curve. So obviously explosive growth, and hopefully you have a sense from what I've already discussed as to why that happened, why it's happening still. This is an article that I highly recommend if you're interested in the history and this question of like, why did all this suddenly take off? Where did it come from? And you can, when you go to my slides, this whole image is a clickable image. It will take you to this New York Times article. I do have a URL there as well, the bit.ly link. But take a look at that if you're interested in finding out more. This chronicles how Google itself made the transition to deep neural networks for the Google Translate service. And it's quite an interesting story and revealing as well about the technology. Let's see if I can get back into slide mode. I think I'll increase my screen, full screen. There we go. Okay. I don't have to tell you how important this technology has become because you're seeing headlines every day about it. And, you know, I think it's very good idea to take a lot of those stories with a grain of salt, because we're sort of also in the era of overhype, where I think people are a little too quick to herald the beginning of a new age, when, you know, there are great advances happening, but they're maybe not as far reaching as the media may depict them. But I'm going to give you just one example of one that kind of blew my mind, which was that there was a neural network built to look at retinal images to diagnose, I think it was diabetic retinopathy. So they were trying to diagnose a very specific condition. And what they found was that there was a very strong correlation with the findings of this network with cardiovascular disease or pre-cardiovascular disease. And so the net result was that scanning images and using this technology was a way to actually detect that someone was in danger of having heart problems or cardiovascular problems or stroke. And this was totally unexpected. So it's one of these things where the technology is sort of taking us in directions we didn't even know we needed to go or wanted to go. But, well, I mean, we wanted to go, but we weren't looking specifically for those sorts of results, and we found them. So just incredible things that we're finding with this technology. Now, there are a bunch of different terms that are thrown around in this field. Artificial intelligence, I think of as the whole sort of umbrella of trying to make computers do intelligent things, get insights, and so on. But that encompasses also lots of different techniques. But the technique that we're going to talk about today is machine learning. So it's pretty much what I've described already, taking software and making it learn things from examples. And then deep learning is a particular approach to machine learning, which utilizes something called a neural network. And you probably already have heard plenty about neural networks, but they're basically structures, software structures that enable us to kind of mathematically cascade the input into what we call embeddings or interpretations of that data that give us meaningful insight into it. And that was a lot of fuzzy words. Hopefully you'll get a better sense of what I'm talking about when I go into an example. For time reasons, I'm not going to go through this next set of slides explicitly, but this is just a summary of some of the different techniques you'll find in machine learning. Just to give you a sense that while we're going to be talking about deep learning today, there's all sorts of different techniques that people are using and that are good to know about. You don't necessarily have to be an expert in every one, but it's good to know that they exist and a little bit about what they're all about. And each of these images, if you click through again, will take you to an article about that technology. This one's particularly, I'm a fan of this one because it's a very interactive, cool way of watching how decision trees work. So take a look at that one if you're interested. There's a video for you to watch, something about GANs. Another video, this was the winner of a music generation challenge. And if you click through on this video, it will take you, it's a long video, 10 minutes, but it'll take you right to the part that I found most impressive. You might like another piece better, but it's the first time I've ever seen, I think, where software generated music actually felt real, impressive, like it could have been composed by a human, by a very good human composer. So it's worth taking a look at that. I think it's fun and impressive again. Let's now switch gears and talk about neural networks and the way they work and why they're so effective. So there are two categories in general: supervised learning and unsupervised. Supervised learning means that you kind of know the answer associated with the input data ahead of time. You have all the labels for the data. And that's the area that's typically we focus on with these deep neural networks. And really what we're doing is, whereas in the old kind of fashioned way of programming, I shouldn't call it old fashioned, but I've been doing it this way my whole life, so it feels like the standard way of programming. We take rules, we write these algorithmic rules, and we take a whole bunch of data maybe, and we run it through our software, and the software has encodings that tell it what the answers are. And the machine learning approach is rather we take the data and we throw the answers in, and that's where the supervised learning comes into play. We have all the labels associated with each data item, feed that into the software, and it actually comes out with the rules to explain not to explain necessarily, but to make predictions on the data that it's seen and on any data that it hasn't seen, ideally. So I have this little notebook I've created, and you can investigate it as well, mco.fyi/VML. But I want to just quickly take you there and let you see what it looks like. Because I've tried to make this stuff maybe a little bit more comprehensible in a visual way. So what you can do here is you can choose some coefficient values. First, you select a polynomial order. So for people that haven't seen these in a while, polynomials are constant factors times an independent variable x raised to a particular power. And what we do is we can move these sliders to change the coefficient values, and we get a little of the function below. If we change the constant value, the whole curve goes up or down. If we change the x cubed coefficient, it changes the way the curve bends, essentially. So what we do then is we can say, so we have a curve, and you can think of these coefficients as like the secret values that we made up. You can almost cast this as an encryption problem, but let's imagine the computer doesn't know those values. Obviously it does, because it needed them to draw this nice curve, but just imagine that it doesn't know those. And then I'm going to say to the computer, take a guess on what my curve is. And so it makes a guess like that orange line. Let me blow up the size of this a little bit so it's maybe a little bit more legible. And what it did was it just generated 4 random coefficients for these 4 values. And it just said, okay, here's my guess. Well, not really terribly close. But what we're next going to do is try to use some mathematics to figure out how far away and to see if we can use those guesses to get closer to the line. So I'm going to do learn, and you can see it jumps right away to get right onto that blue line. And you can see the loss is getting smaller and smaller, and after only iterations, the loss is down to 3/10,000s, I think. And you can see the predicted value for each, that's like where it converged, and the actual value is 0.7 and 0.827, so pretty close. And if I do it again, it'll keep getting closer. But one other thing that's kind of fun if you do play with this is if you go all the way down to a first order polynomial, you can reset this. Let's do, yeah, so I set this to 0.8 and 0.2. I'll do a guess and do another guess. I want to get it not quite so good of a guess. Okay, and so what happens is, let me do one more. I want to see if I can get, okay. So down here, if you do a second order polynomial, I automatically insert a 3-dimensional graph. This is the error, like how far your line is away in both dimensions. So the x-axis is the first coefficient, the y-axis is the second coefficient, and the z-axis, the third dimension, is how far away you are from the target. So you want to get that to be lower and lower. And if you watch when I run learn, keep your eye on the orange ball in this 3D graph. It sort of just rolls right down the hill. In fact, if I do this, if I reset, do another guess, didn't seem to do what I was expecting. Try this, reset. Okay, do another guess. Do another guess because I want to start with the ball a little bit higher. Now, if I say just do one iteration at a time, we'll see more atomic behavior. Now, if I click learn, it's just doing one iteration. So it guessed there and the ball didn't move too much. Do another learn. You see the ball each time I click is moving down the hill. And what's happening is mathematically, we're calculating something called the partial derivative of the loss function, which means what direction and how fast should we be turning these, adjusting these coefficients in order to get that ball to the bottom of the hill. There's a certain amount of hand waving going on here without showing you the actual math, but I hope this gives you a sense of what at a high level is going on. Let's go back to the slides, but I invite you to take a look at that notebook because it has more in-depth text explanation of what's going on. Now, already 20 minutes in and running a little late, I think. So I'm going to gloss over this. What I wanted to show you was what I actually do when I do this lab. And it's basically trying to recognize handwritten digits. And the way we do this is we construct a very simple neural network. And this is sort of explaining the mathematics behind what's happening, the stuff I was kind of describing earlier. But the process is generally schematically depicted here. You have the input data, which for the case of the problem where you are trying to recognize handwritten digits, that's kind of a bit map or a pixel map of the handwritten digit. And that kind of, you send that data through a layer, and the layer has these weights and biases that it's using to adjust, to amplify or de-amplify the incoming values, and then pass on, and then it runs those numbers through what we call an activation function, and it passes the result to the next layer. And it sort of will typically cascade through a sequence of layers, and you'll get a prediction. It'll say, okay, based on that input pixel map, I think the probability is that it's a 7, or technically it will say for each of the 10 possible digits, here's a corresponding probability. And hopefully one probability will greatly outweigh the others in terms of its magnitude. And then you'll compare all those predictions for a batch of these digits with the known targets. So again, supervised learning. So what the right answer is, at least for our training data. So we'll compare those and we'll use this loss function, which calculates sort of how far away is this predicted vector from the actual vector. And it'll spit out a result, which is essentially the loss score. And in that notebook I just showed you, that loss score is the z-axis. It's the vertical axis for that, that surface that we were looking at in 3D. So that loss score is essentially an estimate of how close or far away your batch came out from the right answer. And we feed that into the optimizer, and the optimizer says, okay, to get closer, I need to adjust these weights and these amounts. So that's the process. And we just iterate that multiple times with multiple chunks of input. And eventually we get a model that's pretty good or better than pretty good. And we can quantify how good that is according to a set of test data. But the real test, the real question is, okay, we've tested we've trained it, we've tested on our test data. Then we want to actually try putting it through some real world tests where it's seeing data that it's never seen before. I mean, that's actually what the test data is. But I guess my point is that the proof is when you actually have a model that day in and day out is reacting to input it hasn't seen before. So the lab is based on TensorFlow. TensorFlow is a computing tool which is optimized to do symbolic computing of graph computations, which is a very abstract way of saying it's very good at the kinds of computations we typically undertake when we're doing machine learning. It was launched about almost 4.5 years ago. It was internally developed by Google, and it's extensively used in all our products. But it was open sourced early on so that we could both share it with the larger community outside of Google and also get active participation in its development. And I think that's worked out quite well. You can learn more about TensorFlow at TensorFlow.org. If you do get interested in working with TensorFlow, I highly recommend using a library called Keras. Keras started out life as a separate thing, but now it's actually embedded in part of the TensorFlow distribution. So it's an official part of TensorFlow, and I highly recommend using Keras. Why? It provides a higher level of abstraction than the native TensorFlow programming interface. And so it's much easier to use and think about. And I'll show you an example of what a Keras program looks like. So the lab is over here. And I'm actually going to say run all, but we're not going to wait for it because it takes a little while to train these models. But if I blow this up, you can sort of see what this lab does. It will give you the ability to create a handwritten digit model using a neural network with Keras. And at the end of the lab, right in this notebook, you can take your mouse and draw digits like I'm showing in this GIF. And you'll see an estimate on the right of the probability, relative probability for the model, concluding it's any one of those 10 digits. And a lot of this work is based on Martin Gorner's Learn TensorFlow and Deep Learning Without a PhD series. So if you haven't seen that, definitely check it out. It goes way deeper and way broader than what we're talking about here today. And I think it's just it's about the best resource I've seen for diving into some of these deep learning techniques. And I'm just staring at GraphJiggle, which gives me a typo to fix, but it's scary seeing a typo that big. But anyway, I do want to call your attention to one thing here, which is I want to show you what a Keras neural network looks like, because like you'll hear about these things, but you might still want to know, okay, what in the real world, what does this look like? And this is a fairly simple Keras model, but this is Python code, and the way we construct this model is we say tf.keras.sequential, which tells Keras we want to build a sequential model, one layer after another, as opposed to a functional model, which has some different characteristics. But this is sort of the basic and the default way to build a model. So you'd say tf.keras.sequential, and then you pass it a list, a Python list of layers of tf.keras.layers. So you're essentially saying to Keras, here's a list of layers, and here are the parameters for each layer. And so this code looks and feels like Lego blocks to me. You're sort of snapping one layer on top of the other, and each layer has its own parameterization. Like I can specify the activation function, I can specify the input shape, and when we get to a more involved, by the way, this cell's actually running right now. We're on step 4 of training. And as it's training, it gives me the current estimate of the loss function and the accuracy. So it's doing pretty well, but that's on the training data. What we really want to know is how it's doing on the validation data, and that's given by this val loss and val accuracy. Anyway, this notebook will take you through a good network, or sort of a default simple network, a better network, and then a best network. So you'll build 3 networks. The best network looks like this. So there's a lot more layers, and there's a lot more going into each layer, but it ends up doing a really nice job of generating a high accuracy model. And if we have time at the end, I'll come back to this when it's done training, and we'll try and see if we can run that interactive demo. Let's go back to the slides though. And I actually am coming up on, I think I had 30 minutes. So I'm gonna kind of gloss over this and jump to the end. The last section is about the cloud. I'm not gonna go through all this other than to say that what I love about the cloud is it makes me not have to think about all this admin stuff, all this overhead, things like installing software, backing up systems, network administration, blah, blah, blah. All I really care about is solving my problem. I want somebody else to worry about taking care of all the other stuff. And that's really what I think is great about the cloud. We have a bunch of APIs and AutoML services in Google Cloud, which are listed here. Probably don't have time for these demos, but just to say what AutoML is, because I use that term before defining it. The best way to think about AutoML is all of those neural networks we talked about involve all kinds of parameters. How many layers should I have? How many nodes in a layer? What activation function should I use? Should I use convolution between each layer? How big of a convolution mask should I use? Tremendous number of degrees of freedom when you're formulating these models. And the idea of AutoML is let a computer figure out the right architecture and the right structure of a neural network that will give me the best result. So the auto comes from the fact that the computer builds models and it tests them and it just iterates on all that stuff. And as you can imagine, as with any manual task, computers are a lot faster and better at those things than we are. So we've made this capability available to people. We have for every, some of the APIs we have are pre-trained models. So Cloud Vision, for example, is a tremendous data set of images, and we've made that available to you. But it's a fixed data set. It knows a ton about different categories, but it's not readily extensible. AutoML Vision, on the other hand, gives you the ability to extend the domain of an existing network. And the cool thing about it is you don't need as many images as you would need if you were to start from scratch with your own model. So there are a couple demos here of each. I don't know that I have time to run through these, but this one shows a bunch of radiology images of chest X-ray, and it's quite adept at determining whether an X-ray image is showing pneumonia or is a normal result. And this was accomplished with very high degree of accuracy with only 5,000 images. Now, if you really wanted to start from scratch and do that, you'd probably want millions of images. So that just shows some of the power of AutoML. AutoML tables brings the same kind of capability to simple tables. If you have a comma-separated value set of data, you upload the data, you tell Google what column or what field you want to make predictions on, and it will generate a whole bunch of different models in all the different popular categories, random forests, ensemble methods, boosted gradient trees, and everything else. And then it will pick the best model for you based on the results. So super powerful. And the other thing I like about it is it makes it possible to use ML without really knowing what you're doing, in a sense. You don't have to be an expert in ML. It's in that category of I just want to focus on my problem. I don't want to care about all the underlying stuff. This graph's just saying AutoML has been very successful on Kaggle and other places. The last section of the talk is a bunch of resources. There's Martin's site, which I mentioned earlier. And I won't even go through these other than to say this is my top recommended book for Keras. It's written by Francois, the guy who created Keras. And I don't get a commission for this. I just really love that book. Yeah, I'll let you read through these resources yourself. They're all good ways to learn. But depending on what you're particularly interested in, that will kind of drive your journey. We have a free tier at Google. You can get 12 months of access to our cloud for $300 worth of credits for 12 months. And I want to close by just saying that this is one of my heroes, Tim Berners-Lee, the inventor of the World Wide Web. And one of his driving sort of credo was to make the web available for everyone. And I feel the same way about machine learning in the cloud, that we need to make it so that everybody has access to it and can take advantage of it. And it's not just for advanced, researchers or computer scientists. So hopefully that was helpful. I'm sorry for going about 4 minutes over. I apologize for that. I'm happy to take questions, or if we're too delayed, happy to defer and have you just contact me privately.
Hey, Marc. That was some great session. I'm short of words to describe how good the session was. The kind of topic you bring to the session is something that I would love to incorporate to mine. And we have some, we don't have some questions, but we have some compliments or comments from people, and I'd like to tell them to you. I hope I get a professor like him in my master's. That's what Sapnil Jha says.
Very kind. Thank you. Thank you for saying that.
I guess, we have one or two more, I guess, and they'll be turning up. Maybe. Okay, so I guess that's it. And thank you so much, Marc, for your time.
My pleasure. Thank you for having me. Get in touch if I can help you. I apologize for going late again, but have a great rest of your event and good day to all of you.
We'd love to have you again on the on for DSE and other events. Thank you.
Thanks so much.
Thank you. Time for Project Akina. So, those who don't know it, Project Akina is built keeping in mind the simple idea of helping each other in the times of epidemic. I'm not going to tell you all about it and let the team do the talking on this. But I would tell you guys that Akina is a project built on GCP using the capabilities of it. So we have with us here the team to tell you guys more about Project Akina. So coming up first, we have Riddhi Gupta, who's a technology enthusiast and a growing developer. She's a backend developer in DSC VIT. There we have with us Riddhi. Hi Riddhi, welcome to
Yeah,
DSC
hello.
OMG.
Yeah, it's a
Great to have you here. Okay. Next, we have with us Ananya, who believes she is consoling code one bug at a time. Creative code, cubbing, and music defines her. There we have with us Ananya. Hello there, Ananya.
Hi, how are you? How's it going?
You're not completely audible. You can check with the mic once, I guess.
Am I audible now?
Yes, you're audible now. Yes. After
Okay, cool.
ladies, we have with us Mohammad Hisham Akhtar, a backend developer at DSC VIT. He's very enthusiastic about technology and feels like using it for making our life better. That's really a noble thought, Hisham. And welcome on board for DSC OMG. Hisham, you're on mute actually. You need to unmute.
Yeah. Hi Harsh. I'm glad to be here.
Okay, welcome. And wrapping up with his binge watch of The Office, we have Siddharth Verma, Flutter developer at DSC VIT. He stares at an invisible camera sometimes, so watch out for that one. And also, he has a black belt in gift wrapping. Yeah, sure. A lot of cameras on you right now watching Siddharth Verma, and we are more than excited to listen more about Project Akina from every one of you here.
Thank you.
I hope you guys are ready. All the best for the session, and good luck.
yeah, thank
Yeah, so hi Harsh, thanks for that lovely introduction. So hello everyone. Today we are going to be talking about Akina, a project developed during the lockdown phase. We're going to be focusing more on its architecture and how it is becoming fully cloud native. Yeah, today we're going to be focusing on the following. We'll start with an intro about Akina, its features, then we'll talk about our stats, future plans, and how this project made a difference. Then we'll describe the stack we use for this project. And finally, we're going to be talking about DevOps and deployment, our architecture, the issues we faced with our old cloud provider, and how GCP was the platform for our needs. So what is Akina? Akina began with a simple idea during this lockdown phase. The idea was as follows. How can people help each other in this trying time? So we started building Akina, a platform to ask for and share resources. You can even give recommendation for shops which are providing the resources you like someone needs. You can get the latest verified news from the World Health Organization regarding the pandemic. It is the one-stop shop for all COVID-related stuff. Coming to our features include a request feed. Here you can see what people in your area need. You can either chat with them and mutually decide a place to meet and exchange resources, or you can suggest a shop to them. In the news feed, we only bring official news from the World Health Organization to fight the spread of misinformation. There is also an explore section to see NGOs and people working to help the poor and the needy at this time. You can also see all stats related to COVID-19, either worldwide or for stats for each country. You can see the number of active cases, the number of recovered cases, the number of deaths, and the total cases.
So, since the first release of our application, we have had over 230 users and around over 64 requests. We've also collaborated with over 15 NGOs, for example, like Rapid Response and Goonj. You can look at more of the NGOs in the Explore section, as Siddharth mentioned, on our website, akina.dscvit.com. We are extremely happy that our application has been well accepted by the community. And as developers, we are looking to better our application. So we have some future plans for Akina. We are aiming to make Akina a platform to address problems during any disaster, not specific to the coronavirus. We also aim to collaborate with big vendors such as Swiggy and Big Basket so that it aids the delivery process. We also aim to collaborate with NGOs supporting the cause so as to able to reach a larger audience. We worked with a diverse technical team for this project and worked with numerous technologies and frameworks. For this application, we used React to build a web application, Flutter for the mobile application. For our backend, we used Django, Node.js, and fast HTTP with Go for WebSockets. We used Postgres as our database and used Redis for caching. We use Docker for containerization and Traefik for routing and load balancing. I'll now pass it on to Hisham, who will walk you through our approach for a fully cloud-native application.
Okay, so hello everyone, this is Hisham. So before I dive deep into how our application is cloud native and how our approach was actually cloud native, I would like to take like a few minutes to talk about what exactly the cloud is. So after our application is built, there are several ways in which you can actually get it out to the internet, right? So what you can do is you can buy machines like it used to happen in the older days. You can buy machines and you can install them, and you can install the operating system right from a scratch and then deploy your application on that. So that is a very tedious way to do it, and you'd have to pay for the electricity of the machine and its security and all of that. Now enter something like Google Cloud, and what you can do is just on the clicks of your mouse, in like 2-3 seconds, you can actually spin up any sort of computer or anywhere in the world, and you can actually use it to actually host your application or for many other computational purposes. Now, coming to Akina. So when we started, we had a huge team of developers who were comfortable in different frameworks. So to tackle this thing and to make sure that every developer was working on the framework they are comfortable in, we actually ended up deciding that we would build our backend using something known as microservices. So our backend application was actually broken down into 5 different parts, and each developer was assigned one part, and we built that. So that was the first step we took towards actually making our application cloud native. Now, as things actually started, our main aim wasn't to make it really cloud native, but as time progressed, it was pretty evident that we were going to host this on a cloud. Now, we use some really good DevOps practices. So first, to streamline our build, we used a CI/CD pipeline. So there are several ways in which you can actually make a CI/CD pipeline, like Jenkins and GitHub workflows and all of that. So our choice was GitHub workflows. So whenever there was any push to the master branch on our GitHub repositories for any of the microservices, a Docker image was built and pushed to Docker Hub. So now Docker Hub is basically a container registry for all of these images. And Docker Hub is not known for being a bit slow. So we plan to migrate to Google Container Registry in the future. Now, after our images were actually deployed to Docker Hub, we also needed to, get it out on the cloud, right, and to the internet. So to make sure that this process was automated, we made use of something known as Watchtower. So Watchtower is an application that actually listened for any availability of any newer images that were deployed to Docker Hub, and it actually updated our services with it as soon as there was any new build. So as you can see down here, this image actually describes very well how GitHub actually pushed an image onto Docker Hub, and Docker Swarm actually deployed our image. Now coming to Docker Swarm and our entire architecture. So let's talk about this. So first of all, there were 2 types of network traffic that we had to handle. So the first one was HTTP traffic, because of course we were developing a web app. So we had to deal with HTTP traffic. and we had to deal with TCP traffic for our database connections. So HTTP stands for Hypertext Transfer Protocol, and TCP stands for Transmission Control Protocol. All right. So we use several services, and one of them was Traffic. So let's talk a bit about Traffic. All right. So Traffic provided us with a lot of services. So the first one was Let's Encrypt. So Let's Encrypt was a service which actually helped us encrypt our HTTP connection so that we could convert it into HTTPS and make sure everything was secure. Now we actually use Traffic's edge router. Now this edge router is a full-fledged router which provided us with the routing of these two types of connections, and also it provided us with load balancing and reverse proxy for our applications. As Ananya had mentioned earlier, we used Docker to containerize our applications, and we use Docker Swarm, which comes inbuilt with Docker for as an orchestrator. So we do plan to shift to Google Kubernetes engine in the future when our application gets enough traffic to scale it. Now, as you can see here, there were several replicas of our application which were put into place so that our application could scale whenever there was a higher traffic. And to make sure that our application was always up and running, we used observability tooling which was provided to us by Traffic itself. So using that, we could monitor any sort of logs and metrics and make sure that all of our backend instances, all of our containers were healthy and none of them actually had failed. And if any one of them did, then we could actually redeploy it again and make sure that everything was seamless so that users could get a better experience out of it. So that was all about the application architecture. Now Riddhi will tell us about what problems we actually faced.
Yeah, so we faced a lot of issues during the development of the whole project. The idea grew like a child. We had the initial idea of the project in our mind and wanted to reach out to the users as soon as possible so that they can make use of the application and get its benefits. Thus, we gathered some few features that we felt were important. Like mentioned by Siddharth, one of the features was the request speed. We rolled out the version 1 of Akina as soon as possible. And after getting a lot of positive responses, we felt that it would be useful to even scale up the application and add even more functionalities. We found out this other feature that was the explore section, being able to explore the organizations nearby you. And thus, we added that to the application and started on the version 2. We actually faced a lot of issues while building the version 2 of Akina. One of the major issues was network latency. The application became quite slow. And of course, if we had network latency, then we wouldn't be able to support a large number of users. We thus had to address this problem as soon as possible. The other problem that we faced was the database connection leakage. We were very surprised at this weird problem, and often this would bring our whole application to a standstill. The leakage of database connection means that the connections will persist in the database pool even after the transaction got completed and will not terminate. This was a very major issue, and we had to address these two problems as soon as possible. We tried to do a lot of research and find out the reason, and we found that these were majorly due to the old cloud service provider that we were using. We felt that Google Cloud Platform can be an ideal platform for us to shift our application to. Also, as we know, the Google Cloud provides you with a free tier of credits so that we easily shifted our whole application to Google Cloud. We used a lot of resources provided by Google Cloud Platform. Some of these resources were Google Compute Engine and the Google Cloud SQL. Now, Hisham will be telling you more about the specifications of the resources that we used.
Okay, so let's talk a bit about Google Compute Engine. So Google Compute Engine is basically Google's infrastructure as a service. So what it does is that it provides us with a virtual machine on the cloud, and there are a variety of virtual machine types from which you can choose like the different types of CPU, the memory, the operating system on it, and all of that. So for us, we used this particular machine type, and these names are pretty hard to understand if you don't actually go into the console. But it had 2 CPUs and a 2 GB memory, and the good thing about it was that it had the latest Intel CPU platform, which was the Intel Skylake. Also, the availability zone was Asia South 1B, which is actually located in Mumbai, so that most of our users, since they are in India, we could provide them with a lower latency. Also, we have actually used Postgres for our database. So there were 2 ways in which we could actually use Postgres for our database on the cloud. So one of them was actually using Google Compute Engine and installing Postgres on that and managing it on our own everything. So the backups and everything had to be done manually. Now, Google Cloud actually provides us with a very good service for this, known as Google Cloud SQL, which is platform as a service. So in that, Google gives us a managed instance of Postgres, where Google handles all of the backup and replication and everything for us, and it also scales accordingly. And it was very easy to get started with Google Cloud SQL. All we had to do was to just spin up an instance and set the password, and that was it. And we didn't have to go through the trouble of installing everything on a virtual machine. So this Google Cloud SQL we used was in the same availability zone, which was Asia South 1B. It had a storage of 10 GB and a memory of 3.75 GB.
So yeah, shifting our whole application, moving it to Google Cloud Platform helped us to resolve the major bugs that we faced. Thus, we rolled out the version 2 of Akina, and you could find it at akina.dscvit.com. The major issues, which was the network latency, was solved because now we were using the data center's internal network. We ensured that the Google Cloud resources that we are using are in the same availability zone as pointed out by Hisham. This helped the microservices to communicate with each other in a better way and much efficiently, because now they were using the internal network of the data center. We also reduced the problem of the leakage of connections, because now we were using a managed instance of database on the cloud. We also ensured that the resources which are getting used repeatedly are cached, and on the hot path, we use Redis for this purpose. Thus, as you can see, the whole application is containerized and deployed at scale using Docker Swarm. We use Traefik for providing the load balancing, and we are planning to switch to Kubernetes in near future. Shifting to Google Cloud Platform helped us to overcome the major issues that we faced. And we felt that it's important to ensure that the cloud platform that you're using is helpful for you. Thank you. So yeah, here is the whole team of Akina. A huge shout out to everybody, the whole team. Without all of you, the application wouldn't have been possible. Thank you a lot. So thank you DSC OMG and all of you for listening to us patiently. You can head over to poll.dscomg.com to answer the poll questions that we have. Now we are open to questions, and we can have a question answer session.
Sure. That is really some great project, guys. That's one of the best things that I've seen today, at least today. That's one of the best things. There are so many great talks, but this is really mind-blowing. And we have some questions for you. There are some good questions, and I'll just wait. Yes. So this is by Angad Sharma. You mentioned Docker Hub being slow and using Google Cloud Registry for your Docker images. Did you consider GitHub packages?
So we didn't really consider using GitHub packages as our thing because first of all, when we were in our deployment phase, so we actually used Docker Hub. And once it was actually done and everything was actually shifted to Google Cloud Platform, so we thought that actually thinking about using Google Cloud Registry itself, which was a part of Google Platform, Google Cloud, would actually be pretty good. So that was it. We didn't really consider using something else, and we wanted to shift everything to Google Cloud. So the Cloud Registry seemed a good option.
Okay, I believe Angad Sharma got his answer, and we have, I guess, one more question, and I'll be waiting for it to pop up. Yes, okay, it's again by Angad. You talked about the monitoring system in TrayFit. Did you use any reporting tool as well?
So we did not use any reporting tools, but we have a very good dashboard built out for us at the base URL of our API, which is accessible only to the developers, and we check that out every few days so that we can make sure that everything's working fine.
I guess we have one more question. I'm just working with the team. Yes, there's how is your app using microservice architecture?
Okay, so our app is actually the backend of our app is actually divided into several parts. All right. So as Siddharth had actually talked about the different features, so each of that feature was actually wrapped up in a microservice. So the request part was one microservice. Then the shop suggestion part was one microservice. Then the news feed and the statistics part had one microservice. We actually had one microservice based entirely for the authentication to make sure our users were legitimate, and then we had one microservice which actually handled all the chatting within our platform, so that it was pretty great for people to contact each other.
Okay, so that's the end of Q&A round. But I guess we have something for you guys to show. I guess you will be more than excited to see it.
Okay.
Do you see it?
Yeah, we
I'm
do.
a DSC VIT fan for sure. I guess you guys can understand. Samarth
Yes, we
Nair is
do.
the lead at DSC VIT. You can see the support, and that's how our community grows.
Of course.
Yeah.
Yes, that's true.
Yeah.
Okay, thank you for the time, guys. Lovely listening to you. We'll be moving forward with
Thank you
our
so much
session.
for having us here.
Yes, thank you.
Yep.
Thank you. Thank you.
Thank
Thanks a
you.
lot.
Thank you. Okay, just a moment, I guess. Yes. So, tata, bye bye. Sorry, bye. Okay, so coming up, the treasure I mentioned in the start is about to be revealed. And this is the time for, yes, if you guessed it, then it's the Developer Student Club's alumni panel. I remember my journey from the call of my junior Anmol, who wished to set up this community in my college, and it's been a dream run since then. Thank you, Anmol, for this one. This discussion will be about the community impact on personal career, the learning throughout, and the journey after graduations. The panel will be moderated by Swati Singh. First up, we have Saif Ali Sheikh. He's an alumni of DSC Satyabhama University, currently working as developer advocate at Freshworks Inc. Can we have Saif Ali along? Okay. Okay, so meanwhile they add up, I'll be telling you guys more about the other members that they have. Okay, next up there is Nitish Singh Chauhan. Nitish Singh Chauhan is a former Developer Student Clubs lead in Bharat University, Chennai. He is the current CEO and founder of Grey Ships Technologies and Flexava. Sorry if I didn't pronounce it right. Flexava, that deals with sports, fitness, and outdoors, which is running in India, US, UK, and Canada. Another one joining up is Vijay Nandwani. Vijay Nandwani is a technopreneur and the founder of the Espresso Labs. He has taken various leadership roles during his college's days, and nevertheless, to mention that he's an alumni of Developer Student Clubs at Shiv Nadar University. So, all you guys out there at the Shiv Nadar University, we can have a shout out in the comment section. Okay, and also from the Bharat University, not to mention about it. Okay, coming up, there's a very special guest that I know that I've personally met before. I met him in the DSC India Summit. It's Bharat Shetty. We can go on and on talking about this guy. He is the current organizer at GDG Bangalore. Bharat is our go-to guy for community, people, and impact. He is a senior software developer at Nasdaq that's based in Bangalore and New York City. You never grow alone, but always with the community. This started making sense when Bharat started working with the DSC community back in 2017. And ever since then, he has been actively contributing to communities and open source, and was eventually invited to talk about his impact with DSC at Google I/O, which is the official Google Meet and DSC India Summit 2019. That's where I met Bharat Shetty. Next up, we have Nanan Thaman. That's an associate software engineer at Accenture. She led DSC in her campus last year, and she had always stood up for the community by sharing knowledge and helping others. Lastly, we had with us is Meghna. Meghna is a 4 years experienced software developer. She's currently working for SureComp in Germany. We are waiting for the DSC lead panel to start. That's next up. We are super excited for these guys. We are waiting for every one of them. There's Saif, there's Nitish, there's Nandwani, there's Bharat, there's Naina, there's Meghna, and if you guys don't know about how to become a DSC or what does DSC stand for, this community has enormous power, and these guys are living example of it. See, there they come, these guys. We have been waiting eagerly for all of you guys. I hope you guys didn't miss it. I gave a great intro for all of you guys, and we have been waiting long for you, everyone. Nitish, Vijay, Bharat, Naina, Meghna, and Seth, everyone, we are waiting eagerly for you for this session to start, and of course Swati for moderating this session. We all are super excited for this last session of the day, and we want to hear more about your DSC journeys, how you went through the ups and downs, everything. We are more than excited.
When are we going to start?
We are starting right away, and yours is the place. You can start with it, ma'am.
Hi everyone, I'm Swati Singh. I'm leading Developer Student Clubs for Amity University. Thank you to all the panelists for joining us in this panel today. I'm so humbled to be doing this with all of you. So without any further ado, let's get started. First things first, I'd love to know you all more, so it'd be great if you can go ahead and introduce yourself. So let's start with Saif Ali Sek.
Hi all, I'm Saif, just as introduced, and I work as developer advocate at a company called Freshworks from here in Chennai. I am from a college called Satyabama University in Chennai. Yeah, probably that's it.
Cool.
Okay.
Nitish, if you can go ahead next.
Hi, thanks, Swati. Hi everyone. This is Nitish Singh Chauhan, former DSC lead in Bharat University, Chennai. Currently, I am a CEO and founder of Graceive Technology and Flexava. Graceive Technology is a private service-based software company, and Flexava is an e-commerce niche which deals with sports, fitness, and outdoor in Chennai and California, UK, and that's it. Yeah, this is my short intro.
Awesome, cool stuff. Next up is Vijay.
Hello all, I'm Vijay Nandwani. I was DSC lead for Shimnada University in 2017-18. Today, I'm founder and CEO of Espresso Labs. We build Google Home and Alexa applications for enterprises around the globe. Thank you.
Thank you, Mr. Founder. Bharat.
Hi folks, this is Bharat Shetty, and I was the lead for Developer Student Clubs VES University, that is in Bangalore. Yes, currently I am a senior software developer with NASDAQ, and yes, I also lead the Google Developer Groups Bangalore.
Awesome. Naina.
Hi all, I'm Naina, and I was DSC lead from Ludhiana in 2017 and 18, and currently I'm working in Accenture and with Salesforce technology.
Thank you. Hi, Meghna.
Hi all, I am Meghna from India. I'm a software developer working at SureComp in Germany. I am a former Google Student Ambassador. Swati, you can take over.
Yes, thank you for that. All right. I know that you all are from the very first batch of DSC in the world. There was literally nobody to guide you in the process or somebody that you could look up to. So obviously the first question that comes to my mind is, what were your first thoughts when you applied for DSC? And because you were the first one around the world, what expectations or motivation did you have? And I'll go to Saif for that.
I think I started learning about some student programs, reading on Quora. Probably I was pretty much active on Quora that time, and I heard about Google Student Ambassador program and how it was discontinued. And it was my first year when I learned about this, and I always had a cue or some kind of interest towards what this program might offer. But over 1.5 years, I haven't seen any of such offerings from Google or that sort. So I started searching about what campus ambassador programs are and how they are actually different from the current the studies that we do. So how are they different? How would they help me out was my question that I always had. At some point of time, I came across a Facebook post, and then eventually from my college authorities and some of my seniors, I came to learn about Developer Student Club program. And before I applied for it, as you said, it wasn't associated so much around Google. So we know it more of like a Developer Student Club. But most importantly, what I looked at it was it's more like I wanted to do something more than being in the class. I wanted to go out and interact with students or learn something out of the class. But I want my institution to trust me that I will actually do it. And Google gave a right certificate. Okay, now you are a DSC lead. Go do whatever you want. And when you go to the authorities and I say I want to do it, if they ask why and what you want to do it, I can basically show them this is why, and this is the value add that I can bring back to the students. And yes, so initially it was this driving factor that basically helped me understand, yes, DSC lead, being a DSC lead was quite exciting for me, and this was the main driving factor. Yeah.
Indeed. Thank you, Saf. I know trying new things can be daunting at first, especially when you are the first one to try that. But I'm really glad that you applied. Look at you all now. You know, I think it was all worth it. Yeah. So moving on, now that you applied for being a lead, the next thing that comes up is waiting for the selection email. I remember when I got my selection email, which was by Komal Sandhu. It was in January last year. I just couldn't believe that I was selected as a lead. It took me some time to realize that, you know, I was needed to send my confirmation ASAP. So there were a lot of things going on in my head at that moment. So with that, Nitish, what was your reaction when you got on board as a DSC lead, and what's the result expected beforehand?
Yeah, I was extremely happy to receive the confirmation mail from the Google DSC team India, and which also is received by my college management. And same like that's when I was called in front of the chairman of the Bharat University, Mr. Jagat Rakshan. And everyone in the college was very pleased. And same day, even a local media took my interview photos, and that was published in the local regional newspaper. And at the same time, my Jagadarshan, my chairman, also offered me my exam fees, tuition fee extremely for free for my last year of my college. After that, just I was looking forward to next step as a DSC lead in our campus. After that, I did lots of workshop, lots of program, and just now you guys know about me. This thing happened.
Yes, I love that you mentioned that you became a star overnight.
Yeah, sir, yeah, same thing is happened. That day, like in Hindi we said, na, beta tu aaj rato raat start ho gaya. Like that is feeling that time.
I'm sure it was a surreal feeling. Yeah. So we have a Meghna here on the call. She was Google Student Ambassador, acronymed as GSA. Although the program has been discontinued, it would be great, Meghna, if you can share what was it like to be a GSA and how did it help you in your academic as well as professional life?
Well, being a GSA was great. I mean, I was the first GSA from my college and one of the 6 GSAs from West Bengal. So it was like too good to be true moment for me. And as per how this experience has helped me throughout, well, these programs like GSA or DSC does not only like get you updated with the latest tech stack, but also improves your people skills, your soft skills, your team skills, and this are something which you get with experience. And then it opens doors to a lot of new opportunities. You get to meet some amazing people, get inspired, and build your own network. In fact, I would share some of the really amazing things that I learned during this time and has helped me a lot throughout and is still helping me. Like, be different. It's okay. Don't try to fit in, because that way you bring more to the table. Second would be, never say no to a new opportunity or new experiences. I mean, I am in Germany without knowing Deutsch, and trust me, majority of the people over here do not speak English. Make mistakes. Don't be scared. Make many of them and make as early as possible, because the faster you make, the more you learn, and also you get a good time to recover from all the mistakes you make. So do it. And of course, like, dream big, think 10x, always be humble. Right? So yeah, that's all.
Thank you for those detailed points. I really liked the one that do not try to fit in, because then there is no diversity. You're not bringing anything new to the table, so which is very important in communities or in a workforce and anywhere that you go, right? Also, I'd say GSE and DSE are mostly similar. It's just that the program has been improvised and transformed over the years. I know a lot of GSAs who have eventually gone on to have really successful careers. For instance, our program manager of DSE, Nikhil Raichur, he is actually a former GSA. Clearly, this is a testimony to the success of Google Communities, and DSE is no different with that. It's an incredible opportunity for students to learn, teach, and grow. Nana, to add on to that, I'd like to ask you, how did DSE help you as a student leader?
Yeah, so it was an amazing opportunity to be a part of DSC. So DSC not only helped me technically, I mean, we learned a lot, many things. Just to mentor other people, we have to learn things. So apart from technically learning things, I also learned how to manage people, people management skills, and then how to network with people, how to manage stuff. So all these social skills were also part of DSC. Secondly, like we got this opportunity to attend a summit in Goa, and we met so many new people there. We met Google mentors, we met people from all over India. So it was an amazing opportunity that DSC provided.
Awesome. Speaking of impact that you mentioned, we have Bharat Shetty. He's not only a former DSC lead, but last year he took over GDG Bangalore also, that he rightly mentioned. He's a really well-known person in the community, and people actually look up to him for not only what he's achieved in his professional life, but also for his impact in the community. I've actually had the pleasure of listening to him at our DSC Summit last year, where he gave a phenomenal talk on communities and more. So for everybody else on the call today, I'd like to ask you, Bharat, how did DSC impact your career?
Hey, thanks, Swati, for the wonderful, sweet introduction, and kudos to the entire DSC OMG team, for putting this fab event and inviting all of us. You guys are killing it, so congrats once again.
Yay!
Okay, so being a DSC lead, coming to a question, right? There's nothing short of a life-changing experience for me, and I mean that. To be brutally honest, just to add to what Naina said, it was not only about the hardcore dev skills, you learn state-of-the-art machine learning or data science or cloud, but it's also about the people skills, management skills, which we picked at our time of the DSC leadership experience. Personally, it helped me as I came across the role of the Google Developers Group Bangalore, and I'm the organizer here. So that community leading experience is helping me, and it's helping us to run the biggest Google Developer Group community almost in India, and one of the biggest GTDs in the world successfully. Also, it opened a plethora of opportunities, right? So let's say those summits, those conferences, networking, as Naina mentioned. But primarily, I think for me, how it helped in my career is back in my workplace, I wanted to have something of the community essence, right? Developer community. So that's when I went up to my product VP of product, and I said, hey, like this is how things work, and why don't we have one at a workplace and at NASDAQ. So we started a global developer community right here in Bangalore, which opened doors, made it a. So we started from Bangalore and we went global, and we did like a lot of events. We got our CTO and who's of the industry in fintech, and yeah. So I know it's still the beginning of my journey and career. So there's been a leverage, but I think there are many skills which I've picked up in my leadership experience, which will help me across my career, and I'm sure it would help the coming leads, the students here, and your batch as well, Swati, in your professional career as well as your life to go ahead. That's about it, Swati. Thank you.
Thank you, Bharat, for sharing those insights. I'm sure it's going to be, it is helpful for me, but it's also going to be helpful for the future leads. Yeah. Moving on, we have a really interesting question here, which I think is very important to address at this point. And for that, I would go to Vijay. So the question here is, what are the common misconceptions that students have about communities, and how do we combat them?
Right. Thank you, Swati. So, a lot of people, a lot of students think that communities are just for attending events. And some students also consider it not the best use of their time, and they think that maybe preparing for interviews, job interviews, is better use of time. But that isn't necessarily true. There are, I would like to say, three things, other ways in which communities can help students. The first one is networking. At these events and sessions that we organize or attend, we network with so many other people and learn from them. As part of DSC, we also got a chance to go to the summit in Goa, and there we interacted with other fellow DSC leads from around the country and make friends. We also got a chance to interact with people from Google, and their advice that they gave us there is still helping us till date. So I would say communities are a brilliant place for networking and finding the right connections. Second thing that in which communities can help students is impact. And as part of DSC Lead, we made applications and mobile applications for small businesses around the university. And I very clearly remember the smiles on the faces of the business owners when we delivered them the app, and that was helping their business completely for free. So it's a lot of impact that we can make. Me and my team also helped a number of students learn new technologies and help them with their projects. We help them get internships at companies. So the amount of impact that you can make in people's lives with help of communities is tremendous. The third thing in which communities can help and is career. So communities have people, and we generally have WhatsApp and Slack groups for speaking and interacting. And there people can help you with referrals, interviews at companies. They can share the latest resources of latest technologies that can help you learn new things. I mean, would you even believe that today, if I tell you that my company exists because I got involved in the voice ecosystem because I was a part of DSC, I was a DSC lead. So I cannot stress enough how much communities can be helpful, and they're an amazing place for students and people to learn and grow. So I cannot recommend enough to be a part of a community more. Thank you.
Indeed, I really agree with you, because obviously community, I've been a part of community since last 3 years, and being a part of a community, made me feel like I'm welcome somewhere in a group of people where different sort of, people are working in different technologies, they are building new projects. And so they have actually given me a space to, nurture my skills on my own, rather than just, trying to do the cool thing, I would say. So thank you so much, Vijay, for inspiring and making an impact at the ground level. We absolutely admire that. Moving on, since you all are graduated successfully and are also working in industry, unlike us who are in cliffhanger, my next question would go to Meghna. Saf can follow that up. The question is, what is the difference in tech that you see as compared to when you were in college to now after graduation?
Okay. So Technology has been growing really at a rapid rate. We all know that. I mean, when I was in college, only AngularJS was very popular, and now we all know like how many different kind of JavaScripts are there and for different purposes. Oh my God, yeah. So it's amazing and it's crazy at the same time. But I think like after graduation, as long as the attitude is correct and as long as you have the eagerness to learn and try on new things, it's not a problem. So whatever work you get, it might be of different technology or different tech stack, you will learn and you will work on it. And at the same time, the interesting part which I find like as I started working is when I build applications and systems, which we in college also we used to do, but putting them in production and then checking the security, the speed, the scalability of your software, it's just fascinating. And at the same time, like there is some downsides also, like if you have a client or a project which restricts you from using some tech stack, so it was not always a very nice time, but you can choose, I believe. So yeah, so summing up, as long as the attitude is fine, like you have the same college attitude of eagerness to learn and interest in growing, it's gonna be very interesting journey for you, no matter what. Thank you, Swati.
That's awesome.
Yeah, I agree with Meghana on completely. So what I would like to add is that most of the times the main paradigm shift from being in college and working at a company, or I mean actually graduating from the college would be the right term rather than saying at the company, is that in college we are at least I was very much enthusiastic about a lot of different technologies. So when I say technologies, that can be beyond computer science anyway. So I was searching back through what are the hot terms outside. So what is ML, AI, DS, data science, and different stuff. And I ran behind and tried to learn all of them. And somehow the paradigm shift that I learned eventually over time after graduating from the college, and a little bit of hint that I got before from the DSC program, is that anyway, at the end of the day, the technology that you're choosing is a tool, and you're using this tool to solve a problem. And this problem can be a business problem. This problem can be any kind of a problem. But at the end of the day, you are actually learning to use the right tools to solve the right problem. And we often forget that. We often basically start from what's hot, what's in the news, what most of them are using, and try to drive them towards the solution. But what really has to happen is that try to understand the problems first and the nuances around it, and then break down the use case, and then model around what kind of solution you have, and then you get into the stage where, okay, I have to use this particular tool because this gives me this benefit. I have to use this infrastructure because this is very much scalable. And then that is how you approach basically. So I think this is what most of the times inside the college and outside the college, the shift has been.
Yeah, thank you, Meghna and Saf. Well, I got the bottom line is keep yourself updated. Technology is constantly evolving, so are the communities. So we strive to do better with every coming generation. I'm sure there's so much to be done in the coming years. But for now, we're heading on to our last and final question. So for all the future leads that are on the call, I'd like to ask you all, what is the one piece of advice that you would want to give them? So let's start with Meghna.
Adding to all the things and summing up, go get there, do it, don't hold yourself back, and please share your knowledge and inspire people and do cool things that matter. Thank you.
That's cool. Dana, what do you say?
Well, I would say just learn, learn, and learn. There's a lot of opportunity for you waiting. And whatever you learn, just share it with everyone. That's how you grow.
That's nice. Bharat.
Hey, yeah. So, just to add to what these two said, I think when we mentioned about networking, so you guys should network and network not only to network, but also network to make friends. Because when you make friends, that is when your network circle has some value addition to you.
Right.
Also, keep holding the back of your community, sharing knowledge, having mentors, having idols within your community, and do change those idols. Uh, Try to share with your juniors what you have learned, and always find a way to give back to your community. That will also, help you feel much, better, and yeah, do cool things that matter, as Meghna said. Thank you.
That's nice. Vijay.
Yeah, I would say communities and universities a brilliant time for networking. Find the right connections and build things with them, learn with them, grow with them. Yeah.
That's nice. And we have Nitish.
Yeah, I will just say we all belong to the IT sector. To stay in the IT industry, we have to learn the new technology that is always coming. And so keep learning, stay connected with community, keep growing. That's thank you.
Thank you for that. And finally, Seth.
Yeah, in my opinion, soft skills are basically hard to learn, and probably you only get very less chances to basically learn these soft skills. Those don't come from your placement training program unless you actually make them actionable. So I want the future DSC leads to recognize that this is a very great opportunity to put them into action. So recognize the fact that there is a demand where students are looking for skills and which is outside of their syllabus. Look at the fact that your university or your college is always trying to help students to succeed, and look at yourself that Google is actually empowering you, giving you all the resources and trusting you that you are capable of serving all of these three stakeholders. And understand that you have a strategy of 1 or 1.5 years, and subtract all the busy days, and you have 6 months, and try to come up with a strategy saying that, let's say, 3 webinars and I mean, for a month, 2 events. That could be on ML, AI, or whatever the program, DSC program gives you with. Learn yourself, and probably this is when to execute all of these three with the stakeholders that you have in this game, your leadership practice comes into picture. And this is where you need to understand that you have to inspire people to take action, and motivation doesn't basically last long. And this is the information that I can give all the DSC leads out there. Now, making it actionable will only give you experience. Now that you have an opportunity, you have this information, if you don't make it actionable, you don't get experience out of it. So having said that, yes, this is my actionable advice.
Yeah, Swati, here I will add 1 point for future DSC lead.
Yeah, go ahead.
When conducting the workshop in the future, the leads should ensure that the student have the latest technology and software installed in their system, because so that save the time for that lead should send the step by step installation guide before the workshop, whenever they through mail and whatever the social networking they are using. Yeah, because in our time we are facing this problem. That's why I want to suggest to future DSC lead.
Thank you for that. I absolutely loved all the suggestions. So to the future leads who are on the call, please take some inspiration and do good. And so we are on the end of the call. I'd like to say thank you so much for answering all of our questions. I really enjoyed doing this with all of you, and I hope you did too. On that note, I'd like to pass the control to Mr. Host of the today, which is Harsh, I believe. So see you all on the flip side. Bye.
Yeah, that's right. Thank you,
Bye.
Swati.
Thank you,
for
folks. Thank you so much. Bye-bye.
Thank you. Bye-bye.
Nana, Bharat, Naveen, Vijay, Nitish, everyone. It was a ball to have you all guys onboarded with us. Some keen insights, some detailed knowledge, some first-hand information. It's surely a treasure for all those who are wanting to apply for the DSC leads and and they want to know what DSC has to offer for them. Okay. With this, we come to the end of day three. Let's give each other a round of applause in the comment section. Let's show some enthusiasm in the comment section. Do share your experiences on our social media handles with hashtag DSCOMG. We would love to hear from all of you. We are eagerly waiting for that too. And this was just day three. We have lots more in store for you. From DevOps to security, it's going to be a mixed bag of knowledge tomorrow. Today was Harding. A lot of badges were claimed online. You can show off those badges, highly tag us in the post. So with this, stay home, have some good food, sleep well, and don't forget to like, share, and subscribe to show some love for this DSC community and this DSC OMG team who has been working hard for this. See you guys tomorrow evening, same time at 9 p.m. With some more power pack sessions, some more style speakers. Until then, this is your host Harsh Singh, aka Harsh 1298, signing off. Thank you very much and good night.